Good morning, all. So today's session we can start, I think. This is our second day. So today we have 3 technical sessions are there, followed by a special session. I will try to keep the timeline. Okay. Yesterday there was some problem with the timing. So today we will make sure that mic. Okay. Yes, sir. Okay. Okay, today we will make sure that we will keep the timing and delay will be less. Okay, so I hand overing to Kailas to introduce our today's speaker. So today we have Adarsh from Blockchain Academy. Okay, so to Kailas. Hello, Kailas.
Hello, sir. On echo അടിക്കുന്നു. Hello. 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 Sorry for the inconvenience. Good morning. A warm good morning to one and all. A warm good morning to one and all. I, on behalf of our faculty and entire team, welcoming all to the second day of workshop. The first section is taken by Mr. Adarsh S., who gonna take a speech on public blockchain in Ethereum world block computer. He is a research scientist, Blockchain Academy, a convener in Blockchain Academy. I welcome you, sir, to the platform. Sir, please.
Thank you. Thank you for the introduction. So, good morning, one and all. Hope I'm audible. Thanks to Professor Sandeep and the entire LBS team for inviting me to this session. And I see many of my former colleagues also attending this session, like Dr. Deepthi and all. Anyway, a very warm good morning to one and all. Hope we can have a good session. So as Professor Sandeep was mentioning, I'm not going to waste the time here because I know it's already 8 minutes late. So today's session, we will start with the Ethereum public blockchain network. So with the interest of bandwidth, I will stop my video and will start sharing my screen. So hope my screen is visible. You can view the screen. Okay, so yesterday you all might have learned about what exactly is blockchain or what is happening with Bitcoin, the consensus mechanisms and all. There were many interesting sessions yesterday. So today we will quickly jump on to the public blockchain networks, primarily the Ethereum blockchain, or we can call it as the Ethereum world computer. So before going into that, let me just ask you, like, what is blockchain, or what do you feel like whether blockchain is useful or not, or whether blockchain will be beneficial or not? What's your thought? Like anyone can simply just comment on the chat, or you can use your mic also if possible. What's your thought on blockchain? Anyone?
Hello.
Yeah, please carry on.
Sir. Actually, I think blockchain, it is a decentralized application where the nodes are connected peer-to-peer, and where the communication takes place though the parties are not trusted. Means we can means the communication can take place among the peoples though they do not trust each other, and it is completely secure and transparent uh, application. It
Good,
is
good. Okay.
decentralized.
Yeah, good. Very, very good definition. So I think, yeah, that's one of the well-known definitions for blockchain. So I hope you all know what exactly is blockchain. I think you have a fairly good understanding of what exactly is happening in blockchain, and you have studied about Bitcoin also. So Bitcoin was primarily only for the cryptocurrency. Like you have a currency in the network, and you can do only the currency transactions. No other application development or general purpose applications can't be run on Bitcoin. So that's where the relevance of blockchain or a programmable blockchain came into play. That's where we started exploring Ethereum. So just to brush up the things, like if you might have already learned about these things, like it is truly decentralized, it's immutable, and it's instant. So like you can have real-time transactions without any intermediaries or third parties. So that's the beauty of blockchain. That's what, as Ma'am was mentioning, it's a completely distributed ledger of transactions where you can ensure security and transparency even without trusting anyone. Like it is almost a trust-free or a trustless kind of environment. And you can say like this is almost anonymous or pseudo anonymous. Say like you don't want to reveal your identity, or you don't want to do any kind of KYC or any third party verification kind of things. So that is what exactly the Bitcoin's idea of blockchain, or the Bitcoin's idea of distributed ledger bring to this world. And that's where the people started exploring about blockchain. So I think this is a very simple kind of things. If you want to just brush on the things, I would say like blockchain is nothing but a ever-growing book where the blocks form the pages, and when the pages combine together in a sequential fashion, it forms a book that we can call it as a blockchain. And like books are almost static ones, but blockchains are always dynamic. So like it keeps on growing. And why I have just quoted the example of a Harry Potter storybook is like, as you know, every node have the same copy. So if you purchase a copy of Harry Potter, like everyone have the exactly same storybook with them, and nobody can change the story. Even say the author J.K. Rowling is trying to change the story, it is not possible because the copies are already out in the market and it is there with all the nodes. So in a truly decentralized network, when the number of nodes increases, or when the number of participants increases, it becomes really difficult to hack the network, or really difficult to tamper or change the things. So that is the beauty of blockchain. That is how the cryptographic hashing and the consensus comes into play. And you can see I've just put a very basic figure. Hope everyone know this. I don't want to make this boring. Like if you just want to brush up things, you can just go through it. So our primary aim for today's lecture is to focus on the programmable versions of blockchain. That is how you can build your applications, or how you can build your own solutions on top of blockchain. And that is where we have the different models. Say like the first model is a current one, which is more or less the centralized server mechanisms, which is currently being used in almost all the systems, whether it is banking, supply chain, finance, or whatever be the kind of things. You all have the core client server kind of architectures. Even your Facebook, WhatsApp, and all those social media, they have their own web servers. So even though you can tell like ideally internet is decentralized, but it is lying in the hands of some web servers, so you can't tell that it's truly decentralized. Then next you have the public blockchains and the permissioned one, or the private ones. So public blockchains is more or less same as that of a Bitcoin network. That's what we will be focusing in today's session, which is on the Ethereum. And the permission one, I think on day 3 and day 4, you will be having sessions on permission one, that is the Hyperledger and Corda kind of networks, which is I won't call it as a blockchain. It is a what do you call, a distributed ledger with some kind of permissions and restrictions. So this model 2, or the public blockchain, is a truly permissionless public one that exactly replicates the Bitcoin's model, or the entire Bitcoin blockchain model is replicated only by this model 2. That's what we will be focusing in today's session. And moving to Ethereum. I think you are clear with the Bitcoin blockchain network. Ethereum blockchain network is exactly the same as that of a Bitcoin blockchain network with some minor changes or with some very minor changes. So let's go into that. It's completely open source. Bitcoin was also open source. It is public and blockchain based. Bitcoin 2 was the same kind of things. And the third point that makes the difference, it is a smart contract based. We will go into smart contract in depth. Smart contract is nothing but a self-executing program. That is where you can write your code, or you can write your own programming stuff into the blockchain network, and you can start building your applications. So that is not there in Bitcoin network, because Bitcoin, the protocol was already written into the blockchain, right from the first block. The entire cryptocurrency protocol is written. You can't change it or you can't alter it. Only you can do some kind of forking mechanisms. No other changes are allowed in Bitcoin. And the last point, like, it is a truly decentralized and distributed computing platform, like same as Bitcoin also. And you have a native currency token. Like in Bitcoin, you have the BTC, or the coin part. Similarly, inside the Ethereum network also, you have a token mechanism that is just to run the smart contracts or just to run the applications. You need some kind of fuel, or you need some kind of what do you call in some kind of money to be spent, and that is represented in terms of a token called as ether. It is typically mentioned as a three-letter alphabet, ETH or ETH. And as you all know, like, it was launched in 2013. Hope you know, like, Bitcoin, the white paper was launched in 2008, and the network was live by 2009. So hardly after 4 to 5 years, Vitalik Buterin, he was just 19 years of age while he was launching this Ethereum white paper. In 2013, he launched a white paper, and by 2014, it was live. I think the first network was live by 2015. So it's hardly 5 years old, I would say. Like the developers net was live by 2015 only, so hardly 5 years old network. And people started calling it as the new internet or the web 3.0. You know, like currently you are using the web 2.0 or the current internet applications. Web 3.0 means it is a truly decentralized network where anyone across the world can simply join the network. No one can restrict, or no one can censor, or no third parties or middlemen will come and block you or come and attack you. It's like a completely decentralized distributed world, which we will see how things are working. So this is just a basic introduction, just to avoid your confusion between Bitcoin and Ethereum, because commonly people ask, like, okay, Ethereum is another cryptocurrency, or Ethereum is another token. I would say, like, Ethereum have its own token, like it is ETH or Ether. If you are a trader or if you are into cryptocurrencies, you can definitely trade with Ether token also. But the idea behind Ether is not to do trading or not to have a cryptocurrency, because you know, like, Bitcoin have a upper limit. Like there are only 21 million Bitcoins ever in the network, and I think currently more than 19 million is in circulation. But for Ethereum, there is no upper limit, or there is no kind of what do you call, the supply limitation. The idea behind Ether, or the idea behind ETH, is to fuel the network, or to use as a token which will be used to fuel each and every smart contracts or each and every applications which are running in the network. That is just like to help the developers to deploy the applications. That is the idea behind Ether. Just like how you will be using your cloud credits, like your AWS or GCP kind of cloud credits, or how you are going to deploy your website using some droplets or using some paid domain servers and all. So just like how you are going to pay for that, similar to that, you can term like this is a token which you want to pay for using that network. Okay, so moving further, like as I already mentioned, this was started as a white paper in 2013. You can just go and check ethereum.org where the entire details are there. And it was founded by Vitalik Buterin along with Dr. Gavin Wood. Gavin Wood wrote the yellow paper. And then Joseph Lubin. Joseph Lubin is the founder of Consensus also, which is one of the biggest companies in the blockchain world. So these three were the creators. And the interesting part is, like, they founded Ethereum as a fundraiser or as an ICO on top of the a Bitcoin network. Like they raised $18 million in 2013 in terms of a token sale. Hope you know about what is a token sale or what is an ICO in a Bitcoin context. Just like you have a project idea, you tells like, okay, this is what is a current value. Say I have an XYZ project and one XYZ token tends to one USD today. I tell like, okay, you can buy this XYZ token for one USD today, whose value will rise to 10 USD or 100 USD after 3 years or after 5 years. That is the kind of things which I will do with my project. So similarly, they pre-sell this Ether or ETH token in 2013 or using Bitcoin network. Like they raise fund using Bitcoins, and the first network was launched in 2015. I will show you the timeline. Like this is a roadmap. So in 2015 May, the first test network Olympic was actually released. That was just a test net. The Frontier version, that is on 30th July of 2015, that was the first beta version to be released, which was used by the developers as well as the testers for checking the network. And later in 2016, the Homestead version was released. That is where it became more popular, or the common developers or the what do you call it, enthusiasts started trying to work with Ethereum with the Homestead network. And then later on in 2017, they had a new version upgrade known as Metropolis. So I think you have studied about the consensus mechanisms yesterday. There is proof of work, which is the most celebrated one used by Bitcoin as well as Ethereum. But Ethereum have the plan to change from proof of work to proof of stake. You know, like proof of work is nothing but a cryptographic puzzle being solved, and you need to spend a lot of computational power. So the drawback is like you want to have huge computational power, and you need to have that much kind of hardware capacity also. So proof of stake means it's just like betting. Like you are putting a stake for a particular thing. Say like I'm telling, okay, today is Thursday, and I'm putting a stake. But all of you can verify like today is not Thursday, this is just Tuesday. So if I'm going wrong, my stake will be lost, or I will lose the things. So Ethereum also, the idea is like they will migrate from the proof of work to proof of stake, and the work is actually progressing. By the next year, it will be truly moving to proof of stake. There are already some smaller networks which already use a proof of stake network. So the 2007 the Metropolis update was the start of their experimentation on migration from proof of work to proof of stake. Then in 2019, they released the next version of Metropolis known as Constantinople, and there was another update like Istanbul. So here what they actually did is like they uh, did some changes with the mining rewards. Like initially the mining rewards was around 5 ethers, then changed to 3 ethers, and currently just 2 ethers. And ideally they will be reducing the mining rewards, just like the Bitcoin halving. I think you know, like in the early days the Bitcoin mining rewards was 50 Bitcoin, and every 4 years it is halving, say like 50 to 25, 25 to 12.5, and currently in 2020 the Bitcoin mining reward is just 6.75. So similarly, Ethereum also, they are also doing their own things to reduce the mining rewards and moving from proof of work to proof of stake. And very recently, in March 2020, the ETH 2.0. ETH 2.0 means like the next version of Ethereum, which will be truly following the proof of stake. Like they will be following some new concepts like the beacon chain and sharding, where you will have some side chains with the main chain. Just like your spinal cord, you will have a main bone and some sub bones kind of things. So you'll have some side chains which reduces the complexity of main chain, and you can move to the proof of stake. I think I don't want to explain too much on proof of work and stake. And the ultimate aim is to move to the Serenity version. So this version is yet to be announced. Say like researchers predict like by 2021 we will move to the next version, that is the Serenity version. So the thing is like you can see the roadmap. It is hardly 5 years old. I can tell like, and this is in a very early stage. Say like the research is going on and more updates are coming up. So this is the right time from the researcher perspective as well as from the developer perspective to be a part of the network, to contribute to the network and learn from this. Because if you're going to learn CPP, Java or Python, you know, like this is more than 10 years of old, or you need to have a lot of history in the background. But this is the right time where you can be the pioneers or you can be the front runners in this kind of technology. That is what I want to just show with this roadmap. And as mentioned earlier, there is a kind of forking. I think you might have already heard about forking in the first session of Bitcoin. Like forking is nothing but just branching the thing based on some new protocols. Say like, okay, I am telling like currently we all are in work from home mode, or we all are in a COVID pandemic situation. Say from tomorrow onwards, I'm telling like, okay, we will go to office. Some other people tell like, okay, we may not be going to office, we will be in work from home mode, which means like at that juncture you have a you have a branching where some people opt for work from home mode or some people opt for a go to office kind of mode. So that kind of protocol changes can happen based on some new inputs. So here you can see some of the forking which happened in Ethereum, and not going into the Bitcoin forking because I think you have already learned about the Bitcoin forking in the last session. The Ethereum started in 2015, and in 2016 they just stopped the frontier version because that was just a very basic thing, and they started the Homestead version. And in 2017 there was a major hack in the Ethereum network. Hack in the sense like one of the first dApps to be released on Ethereum was known as DAO, or Decentralized Autonomous Organization, which raised more than 15 million in 2016, that period. But there was a flaw in the smart contract where an attacker drained a lot of money from the network. So at that time, since there are very few applications on Ethereum and most of the money was stuck in that particular attack, Vitalik Buterin and his team was forced to revoke a block. This was actually against the principles of a blockchain. As you all know, like once a block is created based on the principles of blockchain, you cannot roll back or you cannot change the things. So there was a huge controversy happening in Ethereum in 2016-17 period, like whether you can roll back or whether you can revoke or not. But again, with the interest of the community, because many people got their money stuck in the network, so Vitalik and his team was forced to do an illegal thing, which means like they had to roll back that block, and that is where it split into two in 2017 October. The people who followed the basic network forms the Ethereum Classic, and the new network forms the Ethereum Metropolis, or the ETH community. So Ethereum Classic, even though it is sticking to the basic blockchain principles, but it have very less developer community support, and not much people are actually supporting it. Even though the network is still live, but the developer support is very low. But Vitalik and the entire Ethereum team is still following this main chain, that is Ethereum Metropolis, then the Constantinople, and will come up. So even though you can argue like, okay, the current Ethereum network, it have a crime in the backend side, like once it roll back the all the basic principles of blockchain and reward the things. Yes, I would definitely admit that. And Ethereum Classic is a true blockchain network, which you can say like it have never reverted back, but still the developer support or the community support is much less, because you know, like Buterin, Gavin Wood, Joseph Lubin, all those big players are still in this network. So that's why the developer community is also in this side. So just for your information, say like these things can also happen in the network, but that was happened just once. It never happened again, because now the network is much large, and the smart contracts are also much well developed. You have all the functionalities just like a normal programming language, so no need for this kind of reverting anymore. And the comparison, just like a quick comparison between Bitcoin and Ethereum. You can see that text, like in Bitcoin, you can do only the coin transactions. Say like you can transfer BTCs or Bitcoins between two persons, and that is the only thing which you can do in Bitcoin. In Ethereum, you can transfer ETH, or the native tokens of Ethereum. Plus, you can also send the data part also. Like it's not mandatory that all the transactions should be coin transactions. That's why along with sending, along with that message, like sending 10 Ether from Jade to Pete, I am also setting a condition if Jade's balance is 50 Ether and the date is after 12/11/2019, which means like I can also set a condition with my smart contracts or with my programming part. So this will look more or less same as a normal application, your normal web application or mobile application or Windows application kind of things. This will look as a more normal kind of stuff. So that is the beauty of Ethereum. And the difference, I think you can see over here, both have its own tokens. Bitcoin have BTC and Ethereum have ETH. The block time Bitcoin, even though theoretically it says about 8 minutes, but it will take anywhere between 8 to 15 minutes. And in Ethereum, it takes hardly around 11 to 15 seconds, or ideally 14 seconds is what Ethereum takes, which is much faster than Bitcoin. And the block size of Bitcoin is almost fixed at 1 MB, but Ethereum have a variable block size, say like right from 2 KB till bigger block size based on the smart contracts and the number of transactions. You can have a fluctuating block size to accommodate more transactions. And the scripting is limited in Bitcoin, limited in the sense only some forking and protocol updates can happen in Bitcoin. No other programming can happen. But that is the most important thing with Ethereum. That is, like, you have the distributed data storage plus computing. That computing is done using the smart contracts or the programming part. I think in the coming 2 sessions, like you have 2 more sessions today in Ethereum where you will be learning the basics of programming in Ethereum, and you will go through it. And I think on day 4 and day 5 you have sessions on Truffle, MetaMask, and other advanced tools on Ethereum also. So economic model, like since Bitcoin, the coin size is always limited. It will shrink after every 4 years. Like in 2008 it was 50, and then in 2012 it became 25, 16 it became 12.5, and now it is 6.25. It is almost fixed, I would say. Like there is no exact shrinking in Ethereum, but when the new protocol update happens, they will be reducing it. I think currently it is around 2 ethers, but they will be reducing it to 0.6 ethers very soon when they will migrate to the proof of stake. And the transaction fee in Bitcoin is simple using the UTXO model. I think you might have heard about UTXO model yesterday, using the unspent transaction model. That is just like locking your account, doing a transaction, then only you will unlock the things. That is what happens with a Bitcoin network. But in Ethereum, it's more complex. Complex in the sense, like it actually works just like a bank. There is no locking, there is no direct locking mechanism, but you have 2 types of accounts in Ethereum. I will come into that. You have 2 different types of accounts, and you have the transactions also. And the computational power is either on the distributed storage of Bitcoins, but in Ethereum you have a Turing complete language, and then you have a Turing complete virtual machine known as EVM. That is what which runs the Ethereum. So we will figure it out. Anyway, on a broader perspective, I can just tell, like, Ethereum is a programmable version of Bitcoin, or you are doing some kind of updations on top of Bitcoin network, which makes it more programmable to develop the dApps. That is what Ethereum is. And don't get confused between Ether and Ethereum. Ethereum is the underlying network on top of which we will be developing applications and writing smart contracts. Ether is just the token or just a currency, which I would say, like, this is a fuel of the network, or you can deploy applications or you can run the smart contracts only if you have some ethers in your hand. Then only you can do the things, just to make sure that there is no attack, because only genuine people who have ether in their hand can do the transactions on Ethereum, and which avoids any new party or any unknown entity to do some transactions, because if there is no kind of what do you call it, no kind of fuel in it, anyone can do it. Just compare between a bike and a cycle. Like if you're keeping both a motorcycle and a cycle as unlocked, for a cycle you don't need a fuel. You can simply if you have legs, you can simply cycle it through. But for a motorcycle, if there is no petrol inside, you can't ride it. You may be trying to wheel it, but you can't ride it. So that's the main difference, because here there is no central authorities or no third parties to control the network. So these tokens will be actually controlling the network, just like the Bitcoins which were there. And you can also create new cryptocurrencies on top of the Ethereum network. I think almost all the major cryptocurrencies available in the world, they were started as a ICO or a token on Ethereum network, and when they had sufficient number of nodes, they migrated to their own network. For example, the EOS, Tron, Neo, Tether, all those networks and coins, they started from the Ethereum public blockchain network, And once they had a sufficient number of miners or sufficient number of nodes, then they migrated to their own network. So this is one of the best platform to start your own new cryptocurrency or your own new tokens. And now we'll be moving to the basic stuff, or the science part of Ethereum. So Ethereum primarily works on the basis of a state of the computer, because as you know, it is truly decentralized and distributed, which means all the participants in the network across the world can simply join an Ethereum network if you have a internet connectivity. So how you validate whether you are in the right track, or whether you are getting the right transaction data or not? So that is where they are working on a concept called as state, because I think all of you may be knowing about the input state and output state of any computing thing. Like, you take an input state, do some kind of computing, which will give you an output state. So same is the case with Ethereum also. It always work with the current state, that is what is the data in the latest block, which will be immutable and tamper proof. So if I am into the network, I will check what is the current state which is globally accepted. And if this is the current state, okay, I will just start working from it. Suppose say for example, we all are in a blockchain network. Say I have around 50 participants attending this particular session, and suppose a new person is directly joining to this session. So if he is not watching the live video, or if he's just watching the YouTube recording, he doesn't know what is the current state, or where the current lecture is actually happening. Because if you are in the live session, you know, like, okay, this is a current slide and I'm speaking on this particular topic. So you have to align with this particular thing. Like you can just brush up through the previous slides and you can align with the things. Otherwise, what happens is like, okay, you don't have a central authority, or you don't have a teacher or a admin to ask what is the current scenario. You will be either in some back slides, or you will go to some slides in the future. So you will lose the synchronization. So this is just to make sure that the network is actually synchronized. And nodes is the actual machines which will be storing this EVM state. EVM is nothing but the Ethereum virtual machine. I will come to that. And it's all the participants who are participating in the Ethereum network, and who will be participating in the consensus mechanism. That is, currently it is a mining kind of things. So they can be the nodes. There are different types of nodes. I'm not going too much deep there. There are full nodes, light nodes, and many other different kinds of things. So full node means that they will store the entire history of the Ethereum blockchain. That is, starting from the block 0, what is the current block number, they will have the entire copy with them. But if you are just logging in from a mobile phone or from a normal laptop, you may not be able to run a full node, because you may not be having that much storage capacity or computing capacity. So you can be a light node, or you can be a peer, which will be connecting to some other kind of full nodes. That's also a possibility. And then you have the accounts. So for any person who is onboarding to the Ethereum network, they have their own identity, not in a KYC kind of things, but with some accounts. So there are mainly two types of accounts in Ethereum. First is EOS, or externally owned accounts, which is primarily the personal account. Just like your bank account number, for every individual you can have an account, and there is no limit, like one person should have only one account. You can create as much number of EOS as you wish. And the other thing is a contract account. That is, for every smart contract which is created for Ethereum, the contract will have its own identity, which is known as the contract account. Because say for example, in a classroom, I'm teaching about writing a smart contract for banking. So everyone will have the same logic, and everyone will do the same smart contract. Say like you will deposit some amount, you will withdraw some amount, and all of you will be writing the same code. So how you will differentiate code of person A from person B if it is an exactly same replica? So there, every contract will have its own unique address. That is what is a contract account address, where each and every party will have their own address. And you can also deposit ethers for contract, because if the contract have to self-execute, like without the involvement of any third parties or any individuals, you can also deposit some amount of ethers in the contract account. Otherwise, you can also deploy contract account without any ethers. So only when some individuals come and pay for it, then only it will start working. Just consider a scenario of a petrol pump. So in a petrol pump, whenever you pay for the money, you will get the fuel, or you are actually paying for the things and you will get the fuel. But consider a solar lamp in the street light, or a street light. So every evening, even if they are paying or not, it should actually work. That is, the lamp should have its own meter and its own switchboard, and it should actually work. So that is a two variants. Say like you can have contract accounts with either or without either, plus you have the externally owned account. So it is nothing but a simple wallet kind of mechanism where Ethereum have its own wallets, just like your Paytm or PhonePe kind of things, which will help you to maintain your accounts and store your Ether balance also. We will see it in the examples. I think you will learn about MetaMask wallets and some other examples in today's sessions and the upcoming sessions in day 3 and day 4. Then you have the EVM. EVM stands for Ethereum Virtual Machine. I think all of you will be familiar with the JVM or Java Virtual Machine. Like you have a program code which will compiled and deployed. So any machine which have the virtual machine can simply run that byte code. That is, you don't need to supply the actual program code or actual handwritten code. You can just compile and deploy it as a byte code, and you just need to share only the byte code. So similarly, EVM is a thing which makes Ethereum a global network or a world computer. That is, any machine which have an EVM can be a part of this global virtual computer where this whose state where every participant on the network can store and agree on. Like all the participants in the network will agree, like, okay, this is the current state, and we will keep on working from it. So that is how the things will actually progress. Just like how you actually do the financial transactions, or how you actually take attendance, or all those kind of things. Like you want to have an agreement between all the participants, and which should have its own states. Like if I want to do a financial transaction, I should know my account balance, and based on that account balance only I can trigger a transaction. If I have just 1,000 rupees, I can't initiate a transaction of 2,000 rupees unless I have a credit limit or something else. And say, for example, you're taking an attendance. Say it's an online classroom and you're taking an attendance online. You have to check like whether all the nodes are there in online and they are in the current state. Like some people may just log in and put the mic in mute, or cam in, put the webcam as off, and do some other job. So that won't be agreed. You should have to check whether all the participants or all the students are having in the same state. Like you can just come and verify whether they are live or not. So that is a kind of state. And the transaction, I think you already know about what is a transaction blockchain. It's a formal request. That's a code execution in EVM, which makes a transaction either a completely fulfilled request. That is, a sender can send some transactions or some money or some tokens to a receiver. It will just check whether the receiver address is right or wrong, and whether the sender have signed the transaction properly. And once it is validated by all the nodes, or at least 50% of nodes in the network validates this transaction, you can simply commit the transaction, or that transaction get committed, and it will add on to the block. Same as that of Bitcoin. The only difference is like here you can have transaction, that is, you can have transactions beyond a coin or beyond a token part. Like you can do the general purpose applications also. So these are some of the very basic terminologies in Ethereum which you will come across when you are doing the programming, or when you are doing the things. I will explain each and every one when I'm going in depth. So let me move on to the main part, that is the smart contracts, which is the most important building block of Ethereum. So smart contracts is nothing but self-executing programs, just like how you are writing your programs in CPP, Java, or Python kind of things. But why we are calling it as smart contracts is like, even though it is a program, we will be primarily focusing on the business logic. That is, what exactly is the business domain and how things should work, or that protocol will be actually written in the smart contracts, not just a print statement or something of that kind which you write in program. The core business logic where two parties can come and collaborate, or multi-party agreements can happen. So that kind of agreements, when formed in a digital format, makes the smart contracts. So here you may not be writing a simple sorting or a simple printf statements for smart contracts. What you will do is like you will define the exact logic. Say for example, I have a supermarket and I have to do the billing with smart contracts. What I will do is like with all the producers and with all the manufacturing units, they will have some barcode or some kind of things which will be read by smart contracts. And what my smart contracts does is like it will fetch the payment from consumer. Say the tax or the GST part will be getting into the government's account, and the remaining amount will be going to my accounts. So I don't need to have a cashier or an accountant over there. The clients simply come and take the products, and they just pay for it. And once the payment is happening, they can just quickly scan the QR or some other kind of things, and uh, you will just take the product, and all the payments will happen. So that kind of business logics will be primarily focused with smart contracts. That is, it can actually store data as well as send and receive transactions, and or even interact with other contracts also. Say like contract to contract interactions is also possible. So anything which can be done in a physical world can also be converted to the digital world by using the smart contracts. So for example, the land registry thing, like you have a physical record for transfer of land, or for renting a house, or for some other properties, or even the banking or the supply chain kind of things. So all those things, say like you're purchasing some product from Amazon. So what you do is like you pay the amount in advance and you wait for your product. So what happens if that delivery is not happening? So if there is a smart contract, what it will do is like, okay, you pay an amount, the amount will be locked in the smart contract. And once you receive the product and it is, the customer is verifying the product, then only that amount will be moving to the receiver's account. So you have a trust like, okay, there is a well-defined contract which ensures like, okay, my amount is not wasted, or I'm not losing my money. So this is highly useful when you are dealing with anonymous entities or untrusted entities, or where you doesn't know what is going to happen with that person, or even with the trusted entities also. Say like even with your friends or family or your relatives also, if you have a fairly good smart contract, that will be easier to make your transactions happen. And as I already mentioned, this is maintained inside the network. That is, the smart contracts will lie inside the blockchain network without any central ownership or control. Like if Amazon is having a smart contract, which doesn't means like Amazon is going to own it. Amazon will deploy the smart contract in the public blockchain network, or in the Ethereum blockchain network. And any consumers who are going to purchase from Amazon, they can just simply come and verify, okay, this is a contract, like I have to pay this amount in advance, or I am taking an EMI, or I am taking a cashback offer, whatever be the kind of offers which Amazon is providing. These are the conditions, and this is how things will be working. If you're agreeing for it, you just take the contract, you make the payment, and you can ensure things are happening properly. So same things happen with supply chain also. Like, a lot of shipping and all those things, it takes huge amount of time. Say shipping will take around 2 weeks to 3 weeks, or even months, or that kind of time is needed. So what if you're going to pay in advance? Like you don't have an assurance whether the product will be receiving in shape, or the product will have the quality. So there you can lock your money in smart contracts, so that the seller can also guarantee, okay, the consumer have locked the money in smart contract. So if I am doing a genuine transaction, or if I'm delivering my product genuinely, I will definitely get my amount. So both the parties have an assurance. That is what is happening in smart contracts. And you have your own specific programming languages for writing smart contracts. In Ethereum, the most famous language is Solidity. There are other languages like Viper, Mutant, LL, and all, but primarily Solidity is the most famous language which is used for writing smart contracts. And for executing the smart contracts, that is, for executing each and every line of smart contracts, or each and every portion of smart contracts, you need to spend some amount of Ether. That is because just to ensure no illegal entities or no fake entities can simply come and run a smart contracts. Because if I'm a genuine customer only, then only I have to log into Amazon and I have to make a purchase. So for that purchase, I will pay a minor amount of fee, or I'll pay a minor transaction fee for the smart contracts, which will be taken care of by this network. So that is how things actually work, and it's accessible and transparent, like just like the open API. So you can, once you have a contract in place, then you can build your applications, build your decentralized applications on top of this network. That is the beauty of the decentralized applications. So this is actually the two things combined together. Say smart contract, you can think it like a backend code or a server-side scripting, which will be running in the blockchain network, or just like how you are deploying your server-side scripting on the server. here instead of server, you have the blockchain network, and you will write the smart contracts in the blockchain network. And then you have the decentralized application, that is your front-end application, which combines the smart contract with your UI or the user interface. So DApp can be a mobile application, can be a web application, Windows application, whatever be the kind of thing which you prefer. It is similar to what you are actually want your customer to visit. So the customer may not find a difference between whether it is a blockchain application or whether it is a database application, because if Amazon is using blockchain in the backend, the front end or the cart will be exactly the same as that in the current system. The only difference is like you will have the backend instead of server, you will have a blockchain network over there, and instead of server-side scripting, you will have the smart contracts. So many banks, say like in Kerala also, banks like Federal Bank, South Indian Bank, even the Lulu Exchange, all those guys are currently using blockchain networks for their international remittance and payments. So this is an internal process which they use for their international payments. But as a normal customer, say if you're using a mobile app of Federal Bank or a mobile app of South Indian Bank, you may not be knowing whether they have the blockchain in backend or whether they have this thing in backend or not. So there won't be too much difference in user interface. But if you want to make sure that your customer wants to know, okay, I'm running on blockchain, definitely you can figure it out, but it doesn't have huge difference. So that is the beauty of decentralized applications. So it makes it easier for adoption. Say like it's not like a complete disruption which makes all the things obsolete. You can simply switch on from the current applications to the decentralized applications, provided you have a better smart contract and a blockchain network. And the DApp and its backend code will be running on the completely decentralized peer-to-peer network. It is, once it is deployed, it is unstoppable, uncensorable, and independent, which means like it is less prone to attack, and no governments or no third parties can simply come and stop it, because this will be running across all the nodes across the network. So you can't simply stop it. Just like your torrent mechanism, I think you'll be aware about the torrents which you use for downloading movies quite a few years back. Once a movie is in the torrents, you can't simply remove it from a single server or 2 or 3 servers. It will be there in multiple servers. So same is a thing here also. And it's deterministic, like you can perform the same function irrespective of the environment, which means it is one of the most important property of a programming language. Just like it should be deterministic and Turing complete, to make sure that for any input you get the same input, so that you can use it in whatever context you wish. And it has zero downtime and many other features also. Say like zero downtime means you don't face any difficulties, just like the WhatsApp or Facebook, which goes down when there are some issues with web servers, or if some servers are going down. But here, no issues of that kind, because it can run in multiple locations and in multiple nodes. So anyone can simply replicate and run the application. And EVM, as I already mentioned, EVM, I would say, is like the entry point to the network, or which makes like to feel the complete network as a single computer, because you will not feel like you are a simple client, or you are just a peer in the network. You are just a part of the whole computing machinery. Just like all the nodes, I think there are almost 4,000 plus nodes which will be live at any time, and more than 9,000 nodes are actually there in Ethereum network. So all these 9,000 nodes across the globe, they will act as a single computer. That is what the role of EVM, similar to that of a GVM, which I already mentioned. So once you write a smart contract, this will be in readable English language. So you have the Solidity compilers. I think in the next session, you will learn about the compiler and the ID. There is an ID known as a Remix, which is an online ID, which have the Solc compiler, which we use for compiling the Solidity file. And once compiled, you will get the bytecode, which means like you don't have to share your program to anyone. You just share the bytecode, and any machine which have this EVM can simply run it. Just like the same thing which you follow in the Java also. And Java also use the bytecode for running it. So same is the process with Ethereum also. So this makes it a global computer, or what I call as a world computer. So the idea of Vitalik Buterin and team is like in the coming years, across the globe, all the machines connected in the internet will form a part of this Ethereum public blockchain network. And there will be a single world computer, which is in the Ethereum network, like just like the Play Store or any other kind of application portals. Anyone can come and deploy applications on Ethereum. which will be globally available, no region specific or no geographic limitations, and all the applications available across the globe. Anyone can just come and use it, and that's the idea behind this world computer. So some quick statistics, you can see like there are more than 12 crore Ethereum addresses globally. And I also already mentioned no need for like, it's nothing like one individual can have only one account, just like a bank account. Anyone can create as many number of Ethereum accounts as you wish, as I told, the externally owned accounts or EAOs. So you are free to create as many number of accounts as you wish. I think you will see an Ethereum account address in the coming sessions. And there are more than 9,000 nodes globally. So the chances of attacks are very, very less, because as you know, all the 9,000 nodes will have the same copy of the blockchain. And in every 11 to 13 seconds, you will create a new block. So if you want to be a successful attacker, you want to attack all the 9,000 nodes, change the blocks and rewrite the new thing within 13 seconds. So that is extremely difficult process. Even if you are using supercomputers or high power computing machineries, that is a really difficult process, because that's how they have the rewarding mechanism. Like if you are genuine and if you do the mining process, you will get a better reward than attacking the network. And till date, there is still October last, there were more than 888 million transactions which were conducted on top of Ethereum. So you can see the scale of Ethereum. A lot of people are adopting Ethereum for banking, supply chain, finance, and all those kind of things. So a lot of new transactions coming up, and a lot of adoptions are also coming up in Ethereum. So I will move on to the next session, like how the Ethereum works. So if you have any queries, I will just pause for a couple of minutes on the basics, and then I will go to the next session. So I know like the time limit is till 11 o'clock, so I don't want to exceed the time limit. If you have any queries, feel free to ask the queries. Otherwise, I'll move to the next session. Okay. Any queries? Or shall I move to the next session? Okay, so the next thing is about how the Ethereum works. So as I already mentioned about the nodes, accounts, transaction, and other details, Ethereum network, it's just like a simple mobile wallet, like your PhonePe or Paytm kind of things. You have a wallet which will manage your accounts, that is your ethers which are there in the network. And it can also manage your smart contracts, your contract address also. Then you will have your own node. So the node, for every node, that is every machine which is going to be connected, you will have your own Ethereum client. Ethereum client is nothing but a program, a component which will helps your node to connect to the network. So you have multiple clients like Get, Parity, Hyperledger. So many different clients are available in the Ethereum world. You will come to know that. And once the node is getting connected, then you have the dApps, that is a decentralized application, which will interact to the network for a fee. For a fee means like you have to pay ethers for doing some transactions. So this is the basic skeleton of the Ethereum network, or you can say like this is the main things. You have a wallet and a dApp, and then you have the node which will connect to the network. So as a beginner, what you will be actually doing is like, first step is you will be creating, or you will be downloading a wallet. There are many online software wallets available. You can also use other kind of wallets like high security hardware wallets, paper wallets, and all those things are there. But primarily, you can just download a software wallet. You will create your own account. So MetaMask is one of the most common Ethereum wallets which you can create an account. And with that, you will connect to the network. You will have a client which will connect you to the network. And then you will start writing your program, that is the dApp development. You will start writing your code, and that will interact to the network. So as I already mentioned in the first slide, Ethereum works on the basis of state. So you can see, like I have mentioned a very simple example of a door. So you know, like a door can simply have two states. Either it is in an open state or it is in a closed state. So state is a unique configuration of that particular machine. Say like whatever computing you are going to do, it will have its own states from one input state, it will move to an output state, and from that output state, it can move to some other kind of states. So all those states will be well defined, and there will not be any kind of ambiguous states, because if there are some kind of ambiguous states, it will never ever work, or it will actually fail. That is a thing. So that is what you should do with the smart contract. So here in the case of door, you can just see the example. If it is in the open state, say the first stage, the door is open, there is an open kind of things, you do a transition. Transition means from one state you are going to do some kind of transition, and you have a condition also, like, okay, this is the current state, like it is in the open state, there should be some kind of condition. So if a door is opened, I can't open it again, because if I'm putting more force to open it, the door will either break off, or it will not work. So check the condition from the current state, what you have to do, and you have the action, like the transition action, which will move it to the closed state. So similarly, from that closed state, you can have another action, that is to open the things. So each and every state will have its own input and output, and that should be finite. Like, you should not have any open endpoints, or you should not have any ambiguous kind of things that will be happening in the network. That is the most important thing of an Ethereum network. So there is very basic things, which is not the concern of a developer. Like, from the developer perspective, you don't have to worry about these kind of things. This will actually happen internally. That is what is coded in the backend side of Ethereum. So as a programmer, what you will be doing is, like, you can simply write a smart contracts, and the smart contracts will be interacting with the states of the Ethereum network, or with the states which will be the global states. Just like you are defining some global variables, you will have some global states, and every transaction in using the smart contract will be making some changes to that particular state. Okay. And next, once the blockchain is created, as you all know, Genesis block is a very first block, or it is a very first state, which is commonly the blank state, no transaction there. Whenever new transactions get executed, this will move to the new states, that is, state transitions keeps on adding, and always whatever be the current state, that is just like a dynamic storybook, which I mentioned in the second slide. You keep on adding the pages, and every page will have its own story, that is the state transition, or the, what do you call, the kind of computing which is happening with the smart contract. And there is no end point unless the network is truly growing. You will keep on adding the states, and that will keep on growing in all the nodes. This is not just in a single node, but these states will be updated in all the nodes across the world. So you can see, like, why you can eliminate a server, or why you can eliminate a third party is, like, because all the things are transparent here. Everyone in the network knows what is the state of the network. So everyone can simply come and verify whether this is right or wrong, or whether this is a current state or not. So you cannot cheat anyone in this network, because if I'm telling, like, today this is heavily raining in Kerala and this is night here, but if all of you are actually verifying the states from all the nodes in Kerala, you can see, like, this is not raining in Kerala and this is daytime in Kerala. So same as the case, like, you take the states of all the transactions, which make sure that it is trusted and transparent, and no need for any third parties or any central authorities. And once these transactions are related together, you will just keep on adding to the blocks. Like, I think you already know about the block structure. You have a header which stores the basic details of blocks, and then you will list out all the transactions. So in the header, you will have the index, block number, timestamp, Merkle root, and all those kind of things. Here in Ethereum, you use a modified form of Merkle root called a Patricia tree. So it's almost the same as that of Bitcoin. Like, you keep on adding the transactions to the block, and this keeps on moving. And this will keep validating using the proof of work. So till date, this is in proof of work, that is the mining will happen. And in the coming future, it will move to proof of stake. So you can see, like, in the figure, I have started from a Genesis block, the blue color one. Then I have a green chain, which is a canonical blockchain, which I mentioned. And I also have some ash color blocks also. So these ash color blocks are the uncle blocks or stale blocks. That is, at the same moment, there can be more than one blocks which can get created. So say, for example, consider the Genesis block. From the Genesis block, you have one green block which is created. That is the first block 1. And from there, there were 2 options, like 2 blocks were created at that moment. So how the chain grows is like it will check for the longest chain, like who is able to create the next block. So it will keeps on carrying at least till 6 to 7 blocks. It will check whether there are some parallel blocks. Like there can be situations where 2 or more miners can compete and they can create blocks parallelly, but it will not last for long. Like maximum to 6 or 7 blocks it can keep on adding, and then it will always follow the longest chain rule. So here you can see like the green is the longest thing which is growing, because the other thing just dies out because they were unable to create the next block, or it wasn't following the same thing. But that will not be removed from the entire blockchain. What it does is like it will be kept as uncle nodes, or it will store the data assets in the network, and some amount of mining reward will also be given to that uncle nodes. That is a basic protocol kind of things. So from the developer perspective or from a user perspective, you may not be aware of these uncle nodes, or you may not be aware of these side things which are happening. You will just view the blockchain as a single kind of things. You will keep on adding the transactions, and you will keep on mining the blocks and doing your own business. But in the backend, if there are possibilities like multiple blocks gets added at parallel, this can also be one possibility. And that is where the forks can appear. So forks means it is just like branching the chain. So there are 2 types of forks. I'm not going too much detail here. I think you already learned about forks in the Bitcoin session. There is 2 types of forks: hard fork and soft fork. Hard fork means that it's a strict rule, like from today onwards the network is following a new protocol. You cannot roll back, or you cannot follow the old one. Soft fork means like there are 2 conditions: either you follow the old stream or you can follow the new stream. That is the 2 conditions of soft fork. So this is how the things will actually work. So I think with this I will wind up this session. Say like I have already covered the complete working of Ethereum. So I would like to take the Q&A sessions. Say like if you have any kind of queries, or if you have any kind of doubts regarding Ethereum, feel free to ask, because I know like I can't teach the entire Ethereum in just 1 hour or 2 hours. Ethereum, even the developer program lasts for more than 10 days or 15 days. So this is a really vast topic. Each and every slide have its own explanations in vast, which I can't cover completely over here. But we can move to the Q&A session, so that we will make sure that all your queries get answered, and if you have any confusions, we can take it further. So thank you for attending this session. Hope we can move to the Q&A sessions, and I would love to take questions from you, so that all of you will get an idea of what exactly is happening in Ethereum. And in the next session, you will learn about the basics of smart contracts, or how you are writing a smart contract, or how you can do the programming stuff on blockchain. Okay. So let's start with the Q&A session. Feel free to ask me questions if you have.
Sir, good morning.
Yeah, good morning.
Sir, I would like to know, what is this MetaMask actually? Is it a D app, or is it something else?
Okay, so MetaMask is not a D app. MetaMask is a what do you call? It's a software wallet, I would say, just like a normal application. You can get the plugin also. There is Google Chrome and Opera plugins for MetaMask. So what it actually does is like MetaMask helps you to create your own Ethereum account addresses. Say like you can directly create your address using the Ethereum client. I already mentioned like there are many clients like Get Parity and all, but that is purely a command line kind of interaction, which will be difficult for the non-programmers. So what a common man can easily do is like they can simply download the wallet, just like how you are using your phone pay or Google Pay kind of things. You just simply download and install it in your web browser, and within a couple of button clicks you can create your own address. Because I think you studied yesterday, like for any account address, whether it is Bitcoin or Ethereum, you have a private key public key combination. Like you will have a private key, on top of which you will create a public key, And on top of public key, you will use a cryptographic hashing mechanism, just like the SSH256, and you will create a hexadecimal address. So that hexadecimal address is your actual address in the Ethereum network. And it is extremely difficult to remember your private key accurately. Like, like it is almost a 20 byte size. So to remember private key using human brain is really a tough task. So what MetaMask does is like, it will help you to set a password, just like your email ID and password. You can set a password for your account in the MetaMask, and it will also give you a password recovery option, just like there is a 12 seed word password recovery option. You can store your seed words, and if you have lost your password, you have to just repeat the seed words properly. It is just like an interface kind of thing, which helps you to save your private key properly, which helps you to easily create your accounts, and which helps you to manage transactions and connect to the network. Like if you're writing smart contracts with Remix IDE, and if you want to do transactions on the Ethereum network, the MetaMask will help you to connect you to the network, connect you to your Ethereum network and the smart contract, and easily connect the DApp also. So it's like a tool which makes your life easier, like reduces the programming part, and avoid the command line interaction. That is the main thing. Just like how you are using the DOS and Windows kind of things, because you can do all the functionalities of MetaMask by using get client, but you have to code the complete things. Right? You need to write the complete things by code, but MetaMask is just a GUI kind of interface. So hope that answers your query. I think in the next session, you will see what is MetaMask, and you will work on it. So that will be more clear. I'm not going to show you MetaMask here because you have it in the next session.
Yes, we had installed that plugin yesterday, and we did some work
Great.
based on
Okay.
it. I would like to know. So the accounts that we create in MetaMask is actually Ethereum accounts, right?
Yes.
Okay. Thanks. Thank you.
So
Thanks.
if you already installed the MetaMask, then I can tell you, like in MetaMask you have multiple options. Say like you can either directly connect to the Ethereum main network, or you can connect to the test networks. Like there is Robston,
right?
Ringby, Coven,
Yes.
and all. And you can also connect to the local host also. Say like if you want to run Ethereum as a private network within your machine, then you can also run it as a local network also.
Okay, so all this Robston and all, they are actually test networks, right?
Yeah, they are test networks. So because spending real Ether will be expensive, because like it's more than $300 per Ether. So from the developer perspective, if you want to test your smart contracts and if you want to test your DApps, what you will do is like you will directly deploy it either on your private network or on your test networks. So it will have all the features as that of a main network, but the only thing is like you will be just playing with the fake ethers. Like the ethers which you get in the test network is not the actual ones. You will just come and see the fake ethers. So once it is working properly in the test networks, you can compute the expense for your smart contract. You can compute the gas value, gas price, all those parameters for deploying your contract, and you can tell like, okay, I have written a blockchain smart contract for finance or for banking, and for deploying the contract I need 0.2 ethers, and for per transaction I need 0.01 ethers. So these computations will be done based on it's working on the test networks or on the private networks.
Okay, sir. Thank you.
Okay. Yeah. So any other questions?
Sir, hi, good morning.
Yeah, good morning. Please carry
on. Sir, actually, when you talked about this fork, that means uncle blocks and all, right? Actually,
yes.
I am very new to blockchain and all, so I don't know. Sometimes that may be the reason for the doubt. But actually, what is the reason for this creation of these uncle nodes and all? Why it is happening? Or who's creating that?
Okay, so how these uncle nodes actually get created is like, say at a single moment, if multiple blocks are getting created, say, I've already told like there are more than 9,000 nodes in the network. So if you're broadcasting the transactions, these transactions may not be reaching all the 9,000 nodes at once, because there can be some kind of network latency and some bandwidth issues across the world. So there are chances like at some points, two parallel blocks may create at some single instance. So that is a rare possibility, but that still happens. So like at some points you can have two block rewards at a single instance. So what it actually does is like it will keep on checking whether he or she or whether this block can win in the next thing also. So I'll give a simple example, not in the blockchain world, but in a real scenario. Say consider a sports event. Say like you're conducting a 100-meter race, and you have almost 75 participants registered for this 100-meter race, and you know like at a time you can maximum 5 participants or 6 participants can run in the track. So you will be conducting heats. You know about heats, right?
Yeah.
There will be the preliminary qualification round, and from each heats, 1 participant or 2 participant will be qualified to the semi-finals or quarterfinals kind of things. So same is the case here also. Since you have 9,000 nodes here, it will do the things parallelly across the world, which means like there are at some moment there are chances like multiple blocks can be created parallelly. It's just like the preliminary round. So in the next round also, if both these creators say like I am creating one block here in India, and say a person X is creating another block in US at the same moment. So if we both are able to create the next block also, then both that blocks will be added. But at somehow say like I am not able to create the next block, and the person X is going to create the next block. So what happens is like I have shown in that slide. So what happens is like my node or my block will be stopped at that moment, and he will be carrying on with his block. Yeah, you can see like the green will be the most validated one, and the ash one can stop at any moment, which if it is not going to create the next one. So theoretically, at maximum of 6 to 7 blocks can get created as angle nodes, but practically that won't go too much long, because you know like if you know like there are parallel winners or there are parallel blocks, you will try to win the next block by adding on more computational power. So if I know like there is an angle node in US, what I will do is like just to win the next block, I will keep on increasing my computational power. Same as the case, that person will also keep on increasing. So
Sir, then
maybe
how I am, suppose I am, how the person in India will be informed or will be knowing that another person is also
you can,
doing the same?
yeah, you can always check the block explorer. There is a site called Etherscan, which will list out who is a current winner of the block. I will just show the Etherscan. Just a minute. So this is like a global block explorer where you can see what blocks are being added and who is the winner. 1 minute. I will just show that website. Okay, so sorry, I'll share my screen. Okay, so hope you can see my screen right now. This is the Etherscan, which is an online Ethereum blockchain explorer. You can see the total number of transactions, the market cap, all those kind of things, and the latest transactions also. So here you can see the latest blocks. Say, for example, the current block number 1118246, and it is mined by Ethermine. Ethermine would be an mining pool. I think you know about mining pools. It is like a group of miners comparing together, giving a name and start mining so that they get more rewards of that kind. So here you know the winner or who have actually did the things. Like if there are some kind of uncles, I'll just check for the uncles. Yeah, view the uncles. You have an option for viewing the uncles. So you can see like see the block height at 1118251. There was an uncle at 50. Like just the previous position, there was an uncle, but this ether miner, they have either they have increased the mining power or they have did maximum mining, and they win the 51. So if you just go through in the backside, you can see like just a previous block, you have the uncle, and you will either keep on increasing the things. You know the uncle, and you will just keep on. So here I can see like yeah, here if you have seen this 111823130, here from 128 129 there were two uncles, and at 130 the Babel pool was actually winning it. So you can see how the uncles are happening, and what you have to do with the next kind of things. But that is primarily the concern of the crypto mining pools, because they will be concerned about getting the rewards. But from the developer perspective, that doesn't have any impact, because whether your data goes to the actual block or to the uncle blocks, it will lie as in the blockchain. So from the developer perspective or from the smart contract or DApp, this won't be a concern. the concern will be only to the miners just to get the reward. You can see, like, if you check the rewards here, you will never ever see a 0x. Yeah, only there is one 0x account here. That is a individual miner who have mined a block. But otherwise, you can see like all those things are mining pools. That is, those who are actually investing to create mining pools for gaining the rewards. So I hope that answers your query, right? That won't be a big issue for you, and that angle nodes will also be added in the blockchain, or you will have a sidechain kind of things where your transactions will be also listed over here. Okay.
Okay, thank you.
Yeah. Any other queries?
Sir, hello, sir.
Yes, please carry on.
Sir, let me know which blockchain is the best.
So in the public blockchain context, I would say Ethereum is the best because Ethereum have the maximum community support and the maximum number of maximum number of nodes. Because uh, you can say like there are much faster networks than Ethereum. Say like if EOS, Tron, all those networks are faster than Ethereum, but when compared to the scale of Ethereum, there are just hardly 1,000 or 2,000 nodes, or the community support is much less. So in the public blockchain, because all the things have actually started from Ethereum itself, so I would say like Ethereum is the uh, one with maximum community support and maximum acceptance, and it will stay as such for long because you have a fairly good number of developers over here. So the chances of dying out is very less in Ethereum. And for the permission blockchains, say like the context of Hyperledger, Corda, or Quorum kind of things, there the choice should be on the basis of your use case. Say like if you are focusing on the banking transactions or anything on the financial side, I would say like Corda is one of the most prominent because it is formed by the consortium of banks. So you have almost all the banks in the Corda networks, all the prominent banks in the Corda networks, and they have all the functionalities for it. Say if you're focusing on supply chain, Hyperledger Sawtooth will be the best one because it is more or less focusing on supply chain kind of things. And for any other kind of general purpose permission systems, Hyperledger Fabric is the best one. Fabric is used in almost all the permission kind of sense. So depending on the business use case, you can choose from the permission one. That is what you are actually going to implement, or what is your actual application area. Based on that only, you have to choose a network. And for the public blockchains, not just because I'm delivering the Ethereum session, but you can just Google it and check the size of Ethereum and other networks, like, because all the other public networks started from Ethereum. So just to follow the one which have the maximum followers, that's the best option.
So one more question, sir.
Yeah, please.
So whether the government organizations are using this blockchain technology?
Yes. So please don't confuse between the technology and the token part. There are many government initiatives. I haven't put that slide here because that was not in context. Say like Andhra Pradesh is using blockchain for land records and many initiatives. In Kerala, we work with agriculture sector, health record management. We have a government funded, or a government of India funded a vaccine supply chain traceability solution called ImmunoChain, which is already being piloted in Trivandrum. Around 27 health centers, it is already being piloted, which is running on Hyperledger Sawtooth. Like the entire vaccine supply chain data management is there. Then we work in many other domains. So the technology is fairly well accepted by the government in almost all the domains, say like the land registry, the public notary mechanism, health record management, identity management. There are many use cases which are coming up. The only thing is like the token system or the cryptocurrency is not yet accepted as a legal tender. Legal tender, I think you know the definition. For the legal transactions, you are not allowed to use the crypto tokens, but it doesn't means like government can ban a currency, because it is unable to ban a cryptocurrency as it lies in the public network. So that is a difference between context. That is what I was mentioning about Ether and Ethereum separately. Ether is the just a token part of it, but Ethereum is actual blockchain skeleton or the blockchain network. Okay.
Sir,
Yeah, please.
so in Ethereum, there is it needs some gas fee for executing transaction, right?
Exactly.
Okay, so if I implement an application, if I have created a DApp
Yes.
in blockchain, then does that impose more service charge for the consumers, for the customers?
Not exactly, because for initial deployment into the live network, you need some amount of ethers, but that will be, say, hardly based on your smart contract and the app, say hardly zero point 0.1 or zero point 0.2 ethers will be maximum needed. If it is a bigger kind of DApp, say you need maximum of 1 ether or 2 ether. And for the transactions, say like if the customer just want to view the data, so for viewing things, there are some functions which even doesn't cost you any ether. But if you want to write some data, or if you want to put some data into blockchain, then you will have some amount of ethers needed. So this is just like a controlling mechanism, just to make sure that only genuine consumers will come into the blockchain, and not allowing any attackers or any free goers to come and use it. So if you are a genuine customer, say for any banking transaction also, in the backend side, there is a cost for it. Either it is being taken as your ATM service charge or other kind of service charges. Otherwise, you are directly going to pay for your service charge. So same case in Ethereum also, a kind of service charge is there. But when compared to the centralized systems, it will be a much cheaper. Cheaper. That's what I would say. Like even though the ether costs around $300, you don't have to spend 1 ether or 2 ether for each and every transaction. It will be hardly, say, 0.001 ethers or less than that, because like ether is divisible at to 8 places, and even you can extend it up to 16 also in the coming future. So Vitalik and his team is actually trying to reduce the gas cost in the coming versions, because when it shifts from proof of work to proof of stake, the cost will be reduced. Even for deploying the smart contracts also, in the Istanbul update, they reduce the gas cost for deploying the smart contracts. So that won't be a huge expense when compared to the expense for the cloud services, the droplets, domain services, and all those things when compared together. Like as a company, if you're going to deploy your application on a cloud service, or on a droplet account kind of things, then comparing the monthly charges or the monthly expenses, this won't be a huge amount.
Okay, sir. One more question: is there
Yeah.
any micropayment applications using blockchain technology? No.
Yeah, there are a lot of applications coming up. Even there are peer-to-peer transfer applications on blockchain, like without any bank or without any third parties. Just like your WhatsApp, like the account number, or your contact, you can simply send cryptos in between. Or there are many coin exchanges also. I don't want to name the exchanges, but there are many exchanges which helps you to simply do the micro payments, like the peer-to-peer banking, lending mechanisms. Even the Andhra Pradesh government is trying to implement T-chits. T-chits is, sorry, not Andhra, Telangana. Telangana chits, that is a chit funds on blockchain, where you can keep track of your payments, make payments, and all those things can happen on a simple mobile application which runs on blockchain. It's a possibility.
For digital money transfer,
Yes,
other than this
yes,
cryptocurrency.
yes. It need not be a cryptocurrency. Either it can be a fiat currency or a cryptocurrency.
Okay, thank you, sir.
Yeah. Any other queries?
We have one more question in the chat.
Yeah, please carry on.
How we can secure vehicular communication using blockchain?
Okay, so if you are speaking about the VANET and that kind of networks, there are many IoT plus blockchain implementations which are coming up. Say I have very recently, I could say, like the ride sharing applications similar to the Uber and all. I think you may be familiar about Lazus and Car2Go, which are actually ride sharing applications or car rental services, primarily focused in European countries. They uses blockchain. Like you will have a smart card where you can go and take car from any parking lot. You can use it as a pay-per-use kind of model, and you can also invest in cars also. Say like the Verklar network, like they have a network of cars, just like the connected car kind of systems. Mostly they are using the electric cars or the hybrid cars to save the fuel and all. So once you go to the charging centers, or once you recharging it, uh, that payments and all those things will be taken care of by the system itself. So instead of purchasing a new car, like car is actually a depreciating asset. Say like if I'm purchasing a car for 5 lakh today, After 3 years or 4 years, the value will be just 2 lakhs or less than that. So instead of spending 5 lakhs on a single car, you invest in this company where you can put say 50,000 each in 10 different cars. And that cars, when they are being used by the people or when they are using this network, you will get tokens. They have their own tokens similar to Ether or Bitcoin. They have their tokens which will be credited to your wallet, and you can use that tokens for using the car. Say for the daily commute, I need a 2-seater car. For a weekend trip, I need an SUV, or for going with my trips, with my friends, I need a bigger van or something. So I can choose whatever vehicle which is there in the with the company, and I can have it a pay per use kind of thing. So like a car is never ever a depreciating asset. And even Mercedes-Benz, they are very recently released a paper like by 2030, Mercedes-Benz may not be selling any car to individuals in Europe, but they will be having this rental mode. Like the cars will be available in the parking lots. I think in India that is not that much popular because we don't have parking lots in every community over here. But in most of the European countries, you have parking lots in almost all the residential areas. So the company directly will put the cars or put the vehicles in the parking lots, and you can just go and swipe the card and use it like a pay-per-use kind of things. So the life of car, so like hardly 5 years or 10 years will be the life of a car. Or every year, the company can release a new car for the parking lot, because if the Mercedes-Benz predicts like in an individual ownership car or in a private car, the 95% of the entire lifetime of car will be lying as idle in a garage or in a shed. You will be using the car only for 5% of its entire lifetime. Whether you are doing 1 lakh kilometer or 2 lakh kilometer or 10 years or 15 years, most of the time the car will be lying idle in a parking lot or in your house. So what they suggest is like they will be making the car utilize maximum either to shift it to at least 30% is what they are predicting. Yeah, that kind of initiatives are happening mostly with the connected cars, as well as for car rental, as well as car leasing kind of things. So in India, there are no such things. Like infrastructure is one of the important hindrance over here. You don't have parking lots, or you don't have charging point kind of things. It is just coming up. I hope it will happen over here. I have seen some blockchain-based examples mostly in the European context.
So one more question is there.
Yeah, please.
Which one will we use, Hyperledger or Ethereum?
It's Ethereum. It's primarily public blockchain. So what I've seen is in the public blockchain, because they want to primarily all of them are using tokens. So for designing tokens and deploying tokens, Ethereum is the most simple one. Even though you can deploy tokens in R3 Corda, but it's much easier in Ethereum. Sorry, in Ethereum. So I've seen this in public blockchains.
I think no more questions left. So thank you, Adarsh, for coming, and a very good session. I think a lot of questions have been asked by participants.
Yeah. Okay,
so I would like to call Komal to give her opinion about the session. Komal, please.
Yes, sir. Good morning, all of you. I, Mrs. Komal Pardeshi from Walchand Institute of Technology, Solapur, Maharashtra, propose a vote of thanks. Actually, first, I would like to thank AICT and LBS College of Engineering and Mr. Sandeep Chandran for organizing this workshop for all of us, because as blockchain is an emerging technology today, everyone must know about this blockchain. So we are all are thankful to you for organizing such nice workshop for all of us. And on behalf of all the participants, I would like to thank Mr. Adarsh for introducing us with public blockchain and Ethereum, and also clarifying the doubts of all the participants very nicely. So I thank you, all of you, and thank you for organizing such nice sessions for us. Thank you, sir.
So thank you so much for these wonderful words. I think there are many questions regarding contact. I will share. So I will just share our e-learning website, which is by KBA. You can, I know like this is just a basic kind of things. So you can learn with free courses at our e-learning website. There is a program called Certified Blockchain Associate, which is a free program of 30 hours duration. Say like you will have 2 months of access. like I know, like I've just given very basic introduction to blockchain, so you can keep continuing with this initiative. This is a government of Kerala initiative, and there are many other developer programs also in the platform. You can do it, and you can also connect with our formal official channels. I will also give you the official channels. You can connect me at my email ID also. I will give you my email ID. Also in LinkedIn and Twitter also, my ID is Adarsh Sunil. You can connect me in LinkedIn and Twitter. I'm active in LinkedIn and Twitter. Or you can also connect in our official channels. Say we have a formal Telegram group and a LinkedIn group. Most of the KBA blockchain experts, mentors, and all those guys are actually very active in these groups. You can also connect us, even if I'm not available. You can also connect us in that channels also. And if you are interested to pursue with learning blockchain, I would suggest to take this free course of 30 hours with the certified blockchain associate, and you will have 2 months of access. You need to pay only if you want a certificate at the end. That's the only thing. And you can also pursue with the developer programs in Ethereum, Hyperledger, Fabric, Sawtooth, and Corda also in the website. So once again, thank you, Professor Sandeep Chandran, for inviting me, and thanks to the entire LBS team for conducting this wonderful workshop, wonderful FTP on blockchain. Thank you so much. Hope I don't want to exceed your time limit. I know like the other faculty will be waiting. I will wind up my session. Once again, thank you so much.
Adar sir, sorry to disturb you, sir.
Okay, okay.
Adar sir.
Yes.
Sir, Sushil here, sir. Actually, I have joined this Kerala Academy. In this academy, every course is free of cost, or we have to pay something?
This certified blockchain associate, the course is completely free. That is, you will get 2 months of access for this course. You need to pay only for the certificate. Like at the end, if you want to get the certificate, I think the course is around 5,000 plus tax is a certificate course. And for the developer programs, it's like you can enroll for free, but for it's like there are some free contents over there, and but if you're a paid candidate, you will get the complete instructor-led support. Say like there is a one-to-one instructor support and project development kind of things. So for that, you need to pay for it. Say like if you pay for the thing, you will get around, I think it's a 3 months access for each developer program. So that's your choice. So enrollment is almost free in all the programs. Say like you can just log in and see what all things are offered in the course, and all the free materials you can simply access it. And for the instructor support and for the complete project support, say like in developer program, you will be developing complete DApp. Say for Ethereum, you'll be developing complete DApp in Hyperledger Fabric. So the next batch is of Hyperledger Fabric, which will start on November 15th on online mode, where you will get an end-to-end instructor support for 14 weeks if you're a paid candidate. So like you'll be learning the Hyperledger Fabric, and you will develop and complete end-to-end product on Hyperledger Fabric and deploy it on the network. So for that, you need
to Hyperledger Fabric developer course is running, sir, or it will start?
It will start on November 15th.
Okay, sir. I will register for that, sir.
Okay.
Thanks, Lord.
Any other queries? Yeah. Okay. I think if there are no further queries, we can wind up. I don't want to take. It's already 8 minutes late. I know.
Okay. Yesterday they have given complaints that we are extending time. That's why.
Okay. So anyway, I don't want to take it further. Okay. So keep in touch. If you have any queries, you can either mail me, or we can connect it to our official channels also. Feel free to connect me through mail or our channels. Okay. Nice meeting you all. Once again, thank you so much for attending this session. Thank you, sir. Thank you.
So some queries are there. Main thing is recording. I will be sharing that soon. I will be sharing the YouTube channel link. So all the material will be there. And regarding the PPT, some companies are not providing the PPTs, especially KBA. They are not providing the PPT. So whatever provided, it will be available in the resource folder. Okay. You don't want to record. I will be sharing that soon. Okay. So next session is at 11:30. So 20 minutes left. Okay, you can go and come back. Thank you.
ਤੁਸੀਂ ਵੀ ਪੀ ਲਓ ਚਾਹ ਮੈਂ ਧੋ ਦੂੰਗੀ ਕੱਪ ਆਹ ਹਾਂ ਗਲਾਸ ਧੋ ਦੂੰਗੀ
Hello. I think we will wait for 5 more minutes. 11:35 will start.
Okay.
So hello all. I think we can start our session. So this is our second session. So I would like to call Kailas to give an introduction to the speaker. Kailas, hello.
Yes, sir. Next session is taken by Mr. Anand R, who gonna take a hands-on session on Smart Contrast and Solidity Program Language. An engineer from KBA, completed MPhil in Indian Institute of Information Technology and Management, Kerala, and specialized in Ethereum blockchain technology, Corda DLT technology, and decentralization application development, etc. I welcome you, sir, to the platform.
Thank you, Kailas. Thank you all for giving me this opportunity to take a class for you guys. So without further ado, we'll start with the agenda of the session. So in today's session, we'll be learning a little bit introduction into the smart contract, then about the Solidity language in which we'll be developing the smart contracts for the Ethereum environment. Then we will move on to, I mean, after the some theoretical sessions, we will move on to our hands-on session where you guys can do, try the programs that I show you guys. And after that, we have a question and interaction sections. And yeah, so let's move on. Let me just share my screen. Okay, so I'll just turn off my camera. Okay. So I hope everyone is able to see my screen. So today we'll be learning about smart contracts and in particular the Solidity programming language. So let's, without any delay, let's go ahead. So I'll just go through a simple introduction to the smart contract, and then we'll go to the Solidity language. So smart contract is simply just like other contract. It's simply a digital contract, and if you code the program it in a smart, intelligent way, then it will become a smart contract. So it helps you to exchange money, property, share, or tokenize an asset in a transparent and conflict-free way. And you, because smart contracts runs within the blockchain environment, and blockchain environment's main way is to decentralize the entire system, we will be able to avoid a service of the middleman. So let's see. When we have a traditional contract, we have two parties. Then you have to type up, print out as a normal contract, and then go notarize it and authorize it with some notary. A third party notary will be there to authorize that thing, and then then you can begin the execution of that particular contract. In our case, as you know, the blockchain environment is there, so there is two parties there. Then we move on and create a smart contract, and yeah, simply like that, just like that, everything is done within 1 or 2 minutes, and we can start the execution and act accordingly. So that's the difference between a traditional contract and smart contract. In case of a smart contract, we will be creating a contract, and the two parties have to sign the contract physically, then how to move on and how to verify if the actions both parties take are according to the contract. In case of a smart contract, which is about digital, and you can just sign it digitally, and all the transaction or actions that is going through this contract will be governed by the contract itself. So it will be enforcing all these rules. So you don't have to worry about all the details. Next, benefits of the smart contract, or like benefits of smart contract within the Ethereum network, is that you can enable direct dealing with customers. For example, you have a you have a e-commerce site. So instead of currently what happening is that there will be a dealer, and the dealer will be registering the site, and he'll be posting bulk quantities of products in there. But here, if you implement a blockchain and smart contract, we'll be able to deal directly with whoever produced the product and just buy from there. So that will reduce the cost, and there are many benefits you'll be able to customize. I mean, there are many benefits when buying from directly from the producer, and for the producer, he'll get a better price and a better feedback from the customers also. So as part of the blockchain is a decentralized system, so it is a resistant to failure. So just like that, smart contract is running on top of that. So it also inherits all of the features of a blockchain technology. It is immutable. It's fraud detection because, for example, in my case, if I am sending someone some cash or a mail, and if I am able to delete that, then I'll be able to say that I didn't do such an action. So in that case, we won't be able to prove that he did that email. And even if I, for example, if I take WhatsApp Messenger, the WhatsApp Messenger is we can manipulate the messages in the WhatsApp Messenger. It's a fairly simple mechanism. So even if I said, for example, I'm having a conversation with Adarsh, and I send some critical information or critical actions regarding some or some projects or something to Adarsh, and I simply deleted the messages from my end and claimed that Adarsh just popped up those messages in his end. Um, in that case, the dispute might arise, and it will be very hard to resolve those disputes. But the feature of immutability provided by the blockchain will enable us to get all the transaction or all the actions that is done within the environment, and one will be able to claim such action has been happened. Cost efficiency, due to the fact that we can directly interact with the parties, and we will be able to enforce the actions that happens within the environment, rather than like we have simply a contract. In case of a normal contract, we simply have a contract, and we can hope that the other party will do according to the contract. But here we can enforce, so that will lead to cost efficiency and much more auditability. We have a record keeping. I mean, it's kind of a byproduct, because we already have an immutable storage. That means the all the records that, or the actions that happens within the blockchain network will be there forever. So you have a record keeping mechanism alongside it. So let's look at the smart contract in a technical aspect. So it's self-verifying, it's self-executing, and it's tamper resistant. Um, Even though these are there, but if we say that it reduces malicious and accidental events, but if an error occurs from the user part and it's not handled correctly, we might have an accidental event also. But the network, the Ethereum virtual machine actually has three key features to keep them running. So one of them is deterministic. The others are isolation and terminability. So determinism means that anything that happens in the blockchain we will be able to calculate the outcome, regardless of the input. If a state change, for example, Ethereum is a state machine, right? So if a state change needs 0 or more output, we'll be coding in a way that even if there is 0 output or 100 outputs, 0 input or 100 outputs, the output will always remain the same way. We will be able to predict how it will come. So that is determined. So we will be able to determine the outcome of a calculation without any complex maneuvers. So it is determined in technical aspect. And one more thing I like to emphasize over here is that smart contract is a simply name. The program or the developer will be the one who makes it the smarter one. So it's basically a blank slate. You can write anything over there. As part of the economical aspect, it's transparent. I mean, it's running on a public permissionless blockchain. So it will be obviously transparent, and anyone who is an explorer, a block explorer, just like the one Arthur showed in the before the last session, will be able to access the blockchain's content and view it without any permissions or anything like that. We will be able to reduce intermediacy, because we are introducing an intermediate to establish trust. So blockchain is a trustless environment. What happens here is that we will be placing our trust in a program that is vetted by thousands of people, or vetted by all of the parties that is involved within the operation. So here we'll be completely trusting, instead of an intermediary, we'll be trusting the smart contract. So we can establish trust without an intermediary. So yeah. If we consider the transaction and or the cost for implementing a contract in the real life, it will be much lesser in the smart contract way. Then in legal aspects, so I have some points to something to point out. So we can automate it can be automatically executed or controlled, because the smart contract is controlled by the code that is written on the contract. So we can make it react to certain conditions, and we can enforce it without any manual interventions. And the fact that we are coding it, we will be able to mod it or model it in any way that we want. We can use it to represent a legal document, or simply store some data into the blockchain. It's all under our control. And if a programmer or a person is able to implement it correctly with following up all the thinking up, I mean, basically when we cook up as a normal contract, we should be able to cover all the scenarios that will be happening within the contract scenario. So a contract use case. So just like that, if you are able to cover all the conditions, then you'll be able to enforce a better secure smart contract rather than a normal contract. So as you know, the blockchain is a distributed ledger technology, because everyone has the data. I mean, anything that is stored into the blockchain network, everyone has a copy of that. So everyone is able to verify the smart contract content, and that validates or that gives value to that smart contract and any action that is happened over there, because you have thousands of eyes waiting every action that is happening and enforcing everything that happens. As you know, the blockchain is public and permissionless. There are conditions where the smart contract, the parties involved in the contract might be anonymous in sometimes, because if the other party doesn't want to reveal his identity information, then he will remain anonymous forever, because that's one of the features of the blockchain, Ethereum blockchain. Then we have we don't have really have regulators in blockchain network, but if you want, we can introduce regulators to keep an eye on the contracts or smart contracts in the blockchain network. But that's clearly up to us. If you like, that will add another intermediate, but we can add one of those. And one more thing is that the smart contracts are not like a regulator in any way. So it's not regulated. So that's one of the aspects in legal way. Now, yeah. Now the limitations. So as far as we have seen the features and the technical aspects, the economical and legal aspects of a smart contract, just because it's a better way, that doesn't mean it doesn't have a limitation. Every technology will have a con and pro. So let's look at the limitations of a smart contract. So smart contract can only be enforced upon digital assets. So if you can't digitize an asset in the physical world, then you can't really enforce smart contract on that asset. So, or if you can't really digitalize a contract or scenario into the digital world, then you won't be able to enforce the smart contract upon it. So the next point is that blockchain network is decentralized. I mean, the public or the everyone in the network has a equal share of control, but it is not legally regulated. Anyone can like literally do anything, but the constraints are brought up by the contract, but it's not legally regulated or legally vetted or something like that. Interactions, just like I said before, you have to digitalize the assets. So interaction with the real world cannot be bound by the smart contract. For example, you are creating a multi-party system where you want to verify a college's real world identity. Then in that case, you have to go there and physically investigate the college's welfare and all those things, stuff related with the college. Otherwise, you won't be able to do that using a smart contract. You have to do that manually or in the physical world. Basically, the constraints within the smart contracts are some form of a condition, if or else, and we can't really implement any long, sophisticated implementation or variations. It's always some kind of a conditional formatting inside the smart contract. Okay, so that's all regarding the smart contract. So if you guys have any questions regarding those, then we can like take the questions, or I can move on to the Solidity developing language. Okay, so okay, Durga, thank you for that. So let's continue with the Solidity. So for developing a smart contract, we have numerous languages available, but I mean, over the period of time, there has been numerous languages but the only better thing with Solidity is that it always sticks. It sticked from the beginning. It never stopped. The community never stopped developing. It is even developing in a per day basis. I mean, per night basis. Actually, the builds are called nightly, but there is a huge community around Solidity language, and it develops its updates on a daily basis. So Solidity is basically an object-oriented language. It's nowadays there is a new section called a contract-oriented language. So it comes under that section also, because contract-oriented language means basically the contract language that we write for the blockchain technologies. It's a high-level language, but keep in mind that it's a stripped-down version of most of the high-level languages. So Then basically smart contracts programs govern the behavior of accounts within the Ethereum state. So as you know, there are two kind of accounts within the Ethereum: externally owned account, which is controlled by a private key, I mean the user. And then we have the contract address, which is controlled by the code that is written into that particular address. So moving on. Okay, so features. So primarily, the Solidity is influenced with the C++, Python, and JavaScript. And the syntax of Solidity is mostly similar to JavaScript. But keep in mind that the Solidity doesn't have the full functionalities of any of these languages. It does have bits and pieces of some features. So we will be able to implement most of the things basically storing and condition checking is the optimal cases for smart contract development. So it is designed to especially target the Ethereum virtual machine. So yeah, and it is statically typed. So you have to specify the type of the variables and function outputs and function inputs. So yeah. Then, as I told you, it's a stripped down version of main languages. So even though it still supports multiple inheritance and libraries, complex data types like struct, mapping. I'll explain what are those in the upcoming slides. Yeah. So moving on. So let's look at a sample Solidity code and the structure of that particular code. So as you can see, we have this is a little code to store a number and retrieve a number from the blockchain network using the Solidity language. So in the first line, we have to specify. I mean, if whenever we write a code, it will come under some license agreement, because if your company has a custom license, then that will come under that license agreement. Or if you are developing it for an open source community, then it will come under that particular license. So here I have just provided with a GPL, GNU General Public Licensing. That means you can modify it, edit it, or do anything like that. So the first line, we will always, it's the double slash means the comment, just like any other languages. So the first line is used to specify the license identifier. If you have a license, then you can specify it over there. In the second line, you can specify the version of the Solidity language, also the compiler. I mean, both versions will be the same. The Solidity compiler version will be specified in the second line. And after that, you can define your contract. So just like other languages where you define class, you can define a contract using the keyword contract, followed by the name of the contract. Then you can specify the variables. So as you know, Ethereum is a state machine, or like blockchain is a state machine. The variables declared in the inside the smart contract are called state variables, because whenever we store a value into those variables, the entire state of the Ethereum blockchain will be changing. Now, I have another function to write or store a particular number into the number variable, and I have another function to retrieve it. So this is basically the structure of most of the programming language. Programs in smart contract in Solidity follows. Basically, we have the first two lines that defines the license version, and then the version of the Solidity program. Then we have, we can define contracts, abstract contracts, interfaces, libraries. There are advanced concepts, many advanced concepts like that, but basically we can declare a contract after that, and we can write our own code and business logic inside that. Now, state variables. Basically, state variables are permanently stored values within the smart contract storage, and based on the visibility or accessibility we provided, I can just go through who can access that. So this is just who can execute this or who have access or readability access via a program. Other than that, if you have an explorer, or if you have a blockchain node, you can directly explore a transaction and find out what's the data stored. So it's not like any access limitations. Durga asked a question. Functions are built-in or user-defined? There are both functions, user-defined and built-in functions. So we will in this class we'll be going through functions, user defined functions. So yeah, we'll do that in the hands-on session. So if a state variable is declared as public, it will automatically, the compiler will automatically generate a built-in function for that to retrieve the corresponding variable, and public state variable will be accessible to the user. Any child contract or any externally accessible contract, I mean another contract without inheriting a contract, another contract will be able to call the one, and the contract that declare him itself will be able to access that state variable. And if you declare a state variable as private, then the contract and the only the contract will be able to access. And if you put that in internal, then the contract itself and its child contract will be able to access that state variable. So simply saying, state variables are where we store the immutable data of into the blockchain using a smart contract, and you can read them and write them at your will. Okay, so these are the different state variables, types of state variables available in Solidity, or type of not only the state variables, type of variables available within Solidity language. We have Boolean to represent like two state, like binary states. For example, we can use Boolean to represent a door, state of a door, like true for it is open, and false for it is closed. Then we have another option for integer to store natural numbers, or negative and positive numbers, including zeros. Address is a unique data type available to Solidity and other smart contract developing languages in Ethereum, which is used to store the 20 bytes address of Ethereum accounts, both contract and externally owned accounts. Then we have bytes, which can be used to store byte streams. We have I forgot to add another variable is string, which you can use to just simply store text variables into that. Enums are just user defined variables. I mean, you can create user defined types using enums, and we'll see an example for that. Then we have arrays, which is a sequential storage space we can use to store same kind of data types or data in the arrays. Then we have struct, which can be used to group these data types, value types together. Then we have another data type called mapping, which is similar to the hash table, in which we have a key value pair. We have a key, then we have a value. For each corresponding key, we have a value, and just like the hash table, we can store using the key value pair. So those are the value types or variable types available within the Solidity. There are some advanced variables like contract type and function types, but these are the minimum requirements for this lab session. Then EVM stores data in 3 different areas based on the purpose of that data type or variable. So we have storage, memory, and stack. So just a quick note is that everything within not the entire blockchain construct or the application, practically saying there are some data type or structures that we use alongside the blockchain to maintain the index and integrity, all those things, and those things won't be immutable, but most of the things are immutable in blockchain. So just like that, here storage is an immutable place where we can store state variables and local variables of struct and array and mapping or something like that. Then memory is a temporary space where you can store function arguments, the incoming function arguments. You can just process them, and if you want, you can store them to state variables, but otherwise you can temporarily store them. Stack is where where you have able to store local variables and retrieve them when you want to process them. Then we have Solidity functions. We will be writing our logic inside these functions and calling them from outside. So basically, it's a code of arbitrary length, and it will have a certain number of inputs and certain number of outputs based on the code written inside the function. And a definition follows like this: the function keyword is used, followed by the name, and any input parameters alongside their types. I'll show you an example. Then we have the accessibility of the function, followed by the mutability. Mutability means if the function will be able to change the state of, or how will the function call will affect the state of the blockchain. And then we have the return values and their types. So function modifiers. The function will have some modifiers, like they are used to constrain some actions regarding those functions. For example, we can set the visibility or the accessibility to public, private, internal, and external. We'll discuss what are on the next slide. Then the mutability. That means if the function will be able, how the function will affect the state of the blockchain. If it is in the default, and if it is set as default, that means it can read or write from the blockchain. A view means it can only read from the blockchain. It can't write to the blockchain. That means there will be no cost for executing that kind of functions. Then we have pure. They neither have access to state of the blockchain or how can write anything to the blockchain. They are simply there to perform any calculation. If random calculation, you just want to enforce. For example, you want to have a certain way in which you want to calculate the parking fee of a parking lot, and you don't really want to store the fee, but you want to enforce a particular way in which you want to calculate the fee. So in that case, if you can use the pure function or the view function, then if you want to send either, just like the externally owned accounts, we have either, which is mainly used as a mean to process the transaction. Like for example, either is introduced because you guys know about the torrent networks, right? So in torrent networks, the problem with the torrent network is that always people will download. There is no one, there are very less people that is willing to host the data inside the torrent network. All the people just comes into the torrent network, they just download that from the torrent network. But in case of Ethereum, if that happens, just like for a blockchain or Ethereum or Bitcoin, if that happens in the blockchain network, then that will be a horror for our guys. If everyone is doing the transaction and no one is there to do the mining process or the vetting process, then that will be a horror for that. So in that case, we'll be using either as an incentive. So just like that, we can use that either and transfer that to contracts as well. So either is able to hold by the externally owned account address and the contract address. So if you want to have a function to receive either alongside a transaction or a function call, then you can mark that function as payable and then receive. Apart from these, we can create custom modifiers also in Solidity function, Solidity language. So yeah, those are the modifiers available for a function. Then based on the visibility or the accessibility of a function, let's see whoever can access that. So public means that everyone can access. So just like that, a user or externally owned account can access it. A contract account can access it. And not the current contract, but the another contract account can access it. And the current contract can access it. And any child of that contract can be able to access that. Private means only the current contract or where the function is defined, that only that contract will be able to access or execute that function. Internal means the current contract and the derived contract, the child contract will be able to access it. And the external means the user and self and any external contract will be able to access it. It won't be available to the derived contracts. So let's move on. Just like other Solidity languages, sorry, not Solidity language, just like other languages, Solidity also have control structures to control the flow of execution within the function. We have if else, while, do while, entry control loop, exit control loop, for loop. Then we have just like others loop controls like break, continue, and return. Break will break the entire loop. If it's the same for while, do, or for loop, it will break and exit out immediately out of the loop if you call the break. And continue means you can just skip a loop, then we can return. So then lastly, it is the ternary operator is also available in Solidity. Ternary simply means that you have a condition, and if the condition is true, then you have a value, and if it is false, then you have another value. So these are the main things, the basic things that are necessary with the Solidity language. So if you guys have any doubts regarding what we have discussed till now, then we can take it up or we can just move on to the next topic. Okay, then. So we'll go to the next section. So this is just an overview of what will be the entire development phase of a smart contract in Solidity or any languages, just to give you an introduction to this. So basically we'll have, the first step is to create an overall picture about what product you will be releasing and create a roadmap for that particular product. Then do an in-depth research, like usability research means you can say who will be the audience, and what is the existing system, what is the cons for the existing system, what will be the pro if we implement our new system, and what will be the pro if we have a blockchain, what will be the value that blockchain brings into the table. Then we can think about design of the smart contract and start doing that. And when we have a thorough picture of clear definition of the smart contract design, then we can start onto the development phase where we will be coding it out. Then we can manually test the contract, and then move on to automatic testing like unit testing. I mean, the most prominent testing available for smart contracts are unit testing. And if you are still not satisfied with the results, then you can move on to third-party auditing, security auditing frames. There are many security auditing frames spring up these days because of the importance that once you deploy the smart contract, you can't change it. You have to thoroughly check it before actually implementing the smart contract. So once you put that into the Ethereum blockchain network, you can't change that. So that's one of the main problem with the smart contract. You have to be thorough. Just unlike other languages, like for example, if we develop an application in Java or PHP or Node.js, then if we encounter an error, we can just stop the server or stop the application entirely and start on the maintenance and debug it and then rewrite it and restart it again. But in case of a smart contract, you have to be thoroughly trusting it, unless otherwise you have to face the errors that comes after that. And like if you don't have the you don't have the necessary details, sorry, necessary satisfaction, even after a third-party auditing is completed, you can go for a bug bounty program. So bug bounty program is simply you organize a bounty for the bugs. I mean, just simply, I mean, every site that is out there is organizing a bug bounty program. So you can simply organize, publish. I mean, in that case, you can have to publish your code, your entire program's code. So I don't prefer that. Is a better way if you are developing something for a private frame, like even though the smart contract is open, all the other technologies for the UI, the GUI you develop will be proprietary software. So you can just open source your smart contract, because that's so you can only open source your smart contract and open a bug bounty program for that. But the third-party auditing and bug bounty programs are like costly mechanisms, so you only do that if you want to. And then finally, you can move on and deploy the smart contract to the Ethereum main network. So these are the development phases of smart contract, starting by simply doing our normally day-to-day project specification, requirement documentation, then finally ending and in deploying that to the main network. So then these are the deployment phases of Solidities that's made up word by me. So basically what happens, this is a simple concept. This is the development phase of the entire program. So what happens after we code our program? So we simply code. I'm just giving you an overview. After that, we'll be moving on to the hands-on session. So just simply giving you an overview. So we simply write the code. Then we compile the code using something called the Sol-C compiler, and it will provide with too many outputs, but the main outputs that we need to know about are the bytecodes and ABA, because within the Ethereum virtual machine, the smart contracts always reside as bytecode, because EVM can only execute the language that are near to machine code, machine understandable code. So, and then the ABA are just a signature of the functions that are available within the smart contract. I mean, how we can call it, the name of the function, input, output parameters, and if anything else is related. Then after that, we deploy the bytecode to EVM, which will in turn return us with an address which can be used to access the smart contract in the later phase. So how we interact with the smart contract? So currently, after the initial deployment phase, the smart contract resides within the network as the bytecode. So a high-level language won't be able to directly call it. So we have a format. So the format is to first specify the name of the function, then specify the parameters and all these things, then convert that to bytecode calling mechanism and then call the function. So to do that, we need to know the signature of the function. So that in that case, we'll be using the ABA that we received as the outcome as the compilation of the contract, and using it as a reference, we create the particular communication format and then call the function that is deployed, or using the address as a pointer and call the contract. So further on, we'll be going into the hands-on session. So if you have guys have any doubts regarding the theory I just explained, you can go ahead and ask. Otherwise, we can just move on to the practical sessions. Okay. Okay, then thank you for that. Okay, then so let's go ahead and do the practical sessions. Yeah. So yeah. So to simply go for the practical session, we will be. I'll just talk about the components that we'll be using in the practical session. So in the practical session, we will be using an IDE called a Remix to do the programming, compile, and deploy the smart contract to various networks like Ethereum or a simulator called Ganache. And if we are interacting with the test networks, like we can't really deploy to the main Ethereum network because that really needs either. So we'll use the test networks that are developed and maintained by the Ethereum community for us to experiment with us. So we'll be, in that case, we can use the Etherscan to explore that. Then moving on, we have just like the test network. So I'll introduce you guys to a simulation of a blockchain node, because running an actual node is very resource intensive, because you have to perform mining if you want to commit a transaction. So that's very resource intensive. Like for example, if you are running it for a development purpose rather than like actually running it, you'll at least need a minimum of 4 GB RAM, because but you have like the minimum requirements specified by the client. I mean, the client is known as Get or Go Ethereum client, and the minimum requirements for that client is to have like an 4 GB RAM, and that's just their minimum requirements. I never seen that that client run on a 4 GB RAM machine very smoothly. So if you have at least a minimum 8 GB RAM capacity and a 6 GB free memory, then you have a smooth running. But that won't be possible for a normal developer. So the development community of Ethereum have developed, especially someone called a Consensus company. They have developed a framework called Truffle, and as part of it, we have a simulation called Ganache, and I'll introduce you guys to that. Then we have the Solidity language in which we will be coding all these programs. I have a simple program, then later on we will move into a program where we can store the details of the students. I mean, for example, we have a course called CED course, or Certificate in Developer course. So I'm just storing all the details regarding the project submission of a particular batch in the smart contract and retrieving that. So we'll be doing a program for that as a test, and then we'll be using the MetaMask as a wallet for interacting with the Ethereum network, and also for interacting with the test network. So we'll be using this MetaMask to deploy to the test networks, which is actually the same procedure if you have Ether for deploying into the main network. So you'll know how we can interact with the live Ethereum network via using MetaMask, then I'll also show how we can connect it and simulation, or a if you have a running node, in our case it will be a simulation to connect to Ganache and all those things. Okay, then we'll directly start with the Remix ID, where we will be developing our own smart contract. So to launch the Remix ID, you can simply simply go to remix.ethereum.org. I'll put that in the chat. So simply go to http s or http remix.ethereum.org. So before I begin the practical session, most of all of the tools we will be using today is vetted by us. So I have already run it, and all the most of the errors are rectified. So I mean, I'll be able to explain most of the error, but still the Remix ID and all these are like fast growing and developing environment, because blockchain is still a blooming technology. So the development happens overnight. So there might be a new error. So bear with me if we encounter a new. So let's go ahead and see the features of a Remix ID. So in any case, if you are not seeing these icons on the left side, I have a Solidity compiler and a deploy and run transactions. You can just click on this plugin manager. Looks like a plug. So click on that, and in the bottom there somewhere you'll have something called deploy and run transaction Solidity compiler, and you can click activate on those components, because Remix treats these components as plugins. So if you don't already have those over here, then you can just simply go to this section and enable them, or you can just simply click on this Solidity button, then it will automatically enable these for you. Okay, so let's start with the file explorer of the Remix editor. As you know, Remix is an online ID. I mean, you can host it on your computer if you download its source code and compile it and make it. But other than that, the easiest way to access Remix ID is to go to remix.ethereum.org. So it's an online ID basically. It uses the minimum requirement for using is that to have an up-to-date browser. In case of like any browser, just how to be up to date, because in older browsers there are some compatibility issues. So just to have an up-to-date browser. So let's see the file explorer section of Remix ID. As you can see, we already have some files over here. So these are some files or example files provided by the Remix developer, so that we can directly come into the browser and execute them and get ourselves familiarized with. So over the top, you can see there's a plus symbol. Using that, you can create a new file. So every Solidity file has an extension, and it is called .sol. So when creating a new file, you can, I'll just explain how we can create a hello world program, compile it and deploy it on the on a simulation provided by Remix ID. So first, I'll just create a new file, hello world. So you can either provide the Sol extension, or you can just omit it. But in that case, Remix ID will automatically add that extension, and you can just directly start the code. Okay, so I just copy the license identifier version. Okay. As every code, we have the first line as the license identifier, specifying the license identifier. It's as part of the latest addition to the Remix Solidity language. So now, after the version 7.0, you have to specify the license identifier. It's not mandatory. You'll just get a warning from the compiler. Otherwise, there is no problem. But it's always better to specify this. And next line, you have to specify the pragma or pragma, in whichever way you want to pronounce it. Solidity.
Sir, 1 minute. From where did you get that license? We are not able to catch up.
Oh, I just you can just type it like that. I just go. Oh yeah, I
It's
just
not
increase
very
the
clear.
license. Yeah.
Yeah, thank you.
Okay, so I just put that in the chat
Sir,
also.
you can share that the chat window.
Yeah.
That line. Just share that line.
Okay, I have put that in the chat. So it's just a syntax like XPDS license identifier. It's just a syntax, but it's a comment form. So yeah, so Remix has some kind of IntelliSense. Like you can see when we start coding the contract, you can see the IntelliSense and some tooltip are there. But other than that, we have to code everything in the editor itself. So we can specify which compiler we want to use. Like if you give the cap symbol, then any version within the 7 major version 7, and you can use any subversion up to 7.9. So if you provide the cap symbol, it will be like that. But it is always better to log to a specific a compiler version or a solidity language version as a best practice. But I'll just provide the cap symbol for the lab examination. Now, to define a contract, you can use the contract keyword followed by the name of the contract. A best practice is to have the same name as the file to provide with the smart contract. Then open the curly braces and just press enter, and the Remix will automatically close it for you. Just like other languages, you can comment a line by clicking Ctrl+/. So yeah, you can do this. Basically, it's Ctrl+/ symbol. So yeah, if you use that, you will be able to. Oh, sorry, I accidentally stopped the sharing. I'll just start that. Okay, so using this shortcut, you will be able to comment and uncomment if you want to. So yeah, let's move ahead and declare a state variable of the type string. So to declare a variable in Solidity, you have to first define the type, then followed by the name. So I'll just store a message. Let me just store a message. And you can allocate it. I mean, at the time of declaration, you can allocate it a value. So I'll just say hello world. Then the next thing is that we can either do, there are two things in which we can retrieve the value. Is that the first thing is that we can just declare this variable as public. In that case, the Solidity compiler will automatically create a getter function for that specific variable. So let's see how that works. So I mean, the getter function will be something like this function. So to declare a user-defined function, you can use the keyword called function, followed by the name of the function, get message. And if it has an input parameter, I mean, we won't be doing any storing or any actions regarding that. We will be only reading. So then we can specify the mutability. I mean, how it will affect the state of the blockchain. So this will be this function, the get message function, will be only reading from the state. So we can specify it as view. We can specify whoever can access it. Currently, I'll just say public. Everyone can access it. I'm not really restricting the access for execution of this function. So anyone can access it. So it is public, and we can specify the output of the function. We have to specify the types. In Solidity, it's a statically typed language, so we have to specify the output of the function, types of the output. So you can start it with the key using the keyword called retains, open a parenthesis, and then inside that you can specify what will be the output. So in our case, we will be returning this message state variable. So it is of the type string, right? So you can specify string. Then in Solidity, it's one of the addition. If we are using a dynamic variable, because in case of string, we can really specify the size of the string. So we'll be using the keyword memory to specify that it's a dynamic variable. Then open a curly braces, press enter and close it. And we can use the return keyword to specify the value you want to return. In any case, if you have multiple values you want to return, you can just put it in a parenthesis and give them in a comma separated way. And just like over here, you can specify what are the return types, data types. So that is in case of a multiple data type return function. We'll be seeing that also. So let's go ahead and see if I have any. I mean, I already written the code, right?
There's
So
one doubt.
yeah.
So one doubt. What's the need of the string memory as a return string memory? What is that? What's the need of that?
Okay, so string is a dynamic type variable. We can really specify the length
Size
of that.
It, right?
Yeah,
okay.
Length of the storage. So in that case, in I think in Solidity 5.0 version, they have mandated that you have to tag it with the memory keyword.
Okay.
Basically, it is saying that the function arguments are stored in a temporary place, but in case of string, you have to additionally specify that it is stored in memory, just like that.
Okay.
So when I said that when we tag the message or the state variable as a public, there will be a getter message or a getter function automatically generated. The function will have almost the same similar signature over here, but the name will be the same as the state variable. We can go ahead and execute this, and then we will understand what the getter message is and the normal function is. The functionality will be the same. So now that we have written our smart contract, let's go ahead and see if it doesn't have any syntactical errors or it is compiled rightly. So on the left section, you can see there is a symbol of the Solidity language. I mean, this is a symbol of the Solidity language. So you can click on that. And as you can see, there is a blue refresh button. I'll just go zoom it in. So there's a blue refresh button. That means that your contract is not compiled. So let's go ahead and compile the contract. So before that, the compiler has some options. So the first is to select the compiler version or the language version. So here I am using 7.0, so I'll be using that. Then we have, if you want to include nightly builds, as I said, the updation of the Solidity contract comes in a nightly basis. So they call the alpha or beta builds nightly. And if you include the nightly builds, you can see. Okay, so yeah. Solidity the remix ID sometimes gets stuck. So yeah. So as you can see, it is developed on a nightly basis. So not as frequent, but they push the latest editions over here, and you'll be able to use the latest cutting edge Solidity technologies also. I mean, there are not very much difference, but they'll be correcting some simple errors. But the ones named as nightly are the alpha builds. The ones named as commit are the stable versions of that particular version. So we won't be using the nightly builds. We'll be using the commit version. Then we can go ahead and select Solidity. The language we will be using Solidity. Then we can go ahead and I mean, over the history, we have different updations or different evolution that happened to the Ethereum blockchain network. So if you want to compare your contract for a particular version of that evolution, then you can select that one. I mean, like if you want to go for the first version, you can go for that. But if we'll use the latest one, that is the default version. Then, as you can see, before explaining the auto compile, I'll just go ahead and explain the enable optimization. So the remix itself, or the source compiler itself, provides an optimization method, but it's kind of like a experimental product. So use it with care. It will reduce the gas cost for deploying the smart contract. Then, if you have any warnings when compiling, you can choose to hide that, because warnings doesn't stop you from deploying it. Only errors stop you from deploying that. So let's go ahead and compile our contract. So as you can see in the compiler section, you have a button with a jumping refresh symbol and the compile, then followed by the name of the file. So if we go back, where was my tab? Yeah, this was the name of our file. So whenever you selected a file, that will be displayed over here, so that you can make sure that you have selected the file. So let's go ahead and compile it. And if the compilation is correct, then you can see that we can see all these details. I'll explain what are these in a minute. But if the compilation is successful and there is no error, then you can particularly see a tick mark, a green tick mark over here, and some additional details over here. Now, going back to the auto-compile option, if you have enabled the auto-compile option and you change anything on the editor, the remix will automatically pick that up and compile it and show you the error. So basically here I have removed a semicolon and it's saying that it expected a semicolon and it didn't receive, it got a curly braces. So you will have a quick time on the compilation. So let's explore the results of the compilation. So let's go ahead and these are the compilation details. So as I mentioned before, you'll get so many outputs from the Solidity compiler. It's called the Sol-C. We'll get so many outputs. These are the assembly codes or the machine code. So based on this are the gas is calculated. So for each of these instruction, there is a corresponding gas cost, and when you add up all these gas costs, you will get the execution cost for this corresponding smart contract. And then the most important ones outs in these are the bytecode and the AB. So let's just go ahead and just see those things. And let me just yeah, I'll give you in a better way. Actually, I mean, I'll just okay, I'll just put it over there, but we have a better way also. Okay, so I have put it in the chat, but we have a better way of sharing the code, so I'll just get into that. Now, I'm just stopping the share so that I can share my entire screen. So hope you guys are able to see it. So let's see how the bytecode looks. I mean, we won't be able to understand the bytecode because it's in machine language. So I'll just. So this will be the bytecode, and using these objects and opcode, we'll be deploying them into the EVM, and this will be the typical bytecode will look like. So it's basically machine operable codes and machine codes. So by in hexadecimal form and in assembly language form. So yeah, these will be able to executed by the EVM. So let's see how the AB looks like. So AB is a key value pair. I mean, it's a JSON formatted string, and you can see it will always list all the function, the signature of the function. So you can see there are two functions. That is because we have set the state variable as public. That means the compiler will automatically generate a getter function for that. So the signature for the getter function and the function get message that we developed will be available here. Mostly this will be listing the external and publicly be available. I mean, the visibility should be either public or external. Other functions won't be displayed over here. So let's go ahead and see. So basically it will be the signature of the function, and using this we will be able to construct the call data for invoking that particular function. So basically it is saying that if the function has any inputs, if had any inputs, it will be specified over there. The name of the function, get message. It's describing about the first, this function. The name of the function, the output. So over here, you can see the type is string for the output. I haven't provided a label. I mean, if you want, you can provide a label for the return type. Like I'll just provide message. You can provide a return type for the specified function, and then at that time, it will have the name also. So the name, then we have the type of the function, mutability, how the function will be reacting to us, reacting to the state. So view means it will be only reading from the state. Then the type of the function, that means and the type, what it will be able to list in events also in some cases. I mean, we won't be going to that. That's an advanced topic. Then the next function, the getter function, the name will be the same as the state variable. So the message is the name for the function. The output type, everything else will be the same. So as you can see, instead except the name, everything else is same for the getter function also. So that's how the bytecode and the AB looks like. Yeah. So lastly, there are two options: the IPFS and the SWARM. You can publish to IPFS and SWARM. Let's see. I'll just briefly explain about the SWARM and IPFS. They are not like on the context of the session, but I'll just say them. SWARM and IPFS are some two distributed storage systems, right? that comes complements with the blockchain, sometimes with the DApp development also. So SOM, it is another layer. I mean, it's an application that is developed to run alongside an Ethereum network. So it runs. You should already have an Ethereum node set up to run the SOM networks. I mean, to run a SOM node. And on case of IPFS, it's a much better alternative. But as you know, just like the Tor networks, these files will not be staying there forever unless you maintain a node yourself. So if you want to share your source code to a colleague, or in our case, if I want to share the data to you guys, I can just simply publish that to IPFS. So click the button publish on IPFS. So upon completely, successfully doing that transaction, it will return some details to us. So the metadata will contain all the compilation outputs, and the hello world sol will be the source code. So you can just simply copy this this partial URL. I mean, this is just a partial URL. You have to complete it, and go to another tab and type ipfs.io. That is the main site for accessing the IPFS main network. I mean, if you can go directly there, you can download and see how it works. All those things are available here if you want to go. So if you want, after that, just paste the link that we just copied. I mean, it's a partial URL, so you have to complete that, and just simply entering. Yeah, so sometimes storing to IPv6 something. Yeah, so it is completed. So yeah, you can simply go to this location. I'll just put that in the chat also. You can simply go to this location to obtain the source code. So like this, I mean, IPv6 and SOM is just simply, I mean, it's not a blockchain, it's simply a distributed storage system. So using that, we will be able to store, transmit these data alongside PAs or colleagues, or to send someone. So one thing is that this is not a permanent storage. It might be deleted after 2 days or 30 days if someone is not maintaining that. So we shall explain about the IPFS. Can you elaborate which part I should explain again? Okay, to get the link. So after you have compiled, sorry, I just that's a wrong tab. Yeah. After you have compiled it, you have some options below the Solidity compiler. So there you have an option called publish on IPFS. So just simply click that. And after it is successfully completed, you can copy the link. I mean, as you can see under the hello.sol, you can just simply copy it. And then it's actually a partial link. So then go to another tab, then type ipfs.io, and then paste that partial URL. So I just need to remove this extra slash. And yeah, that's how you get the link. I have put that in the chat, so I'll just put it again. Sorry, ipfs.io. Yeah. Okay, I forgot to put the HTTP in the front, so that won't be displayed as a link. So yeah, this is a link to the code. You guys can directly go there. And if you want to visit the IPFS site, then you can go ahead and visit over here. Oh, sorry. I think I kind of like sending these messages privately to Sandeep sir. I'm sorry, guys. I didn't see that. So sorry about that. Okay. So that's how we can share these details to your colleague or anyone else like that. Yeah. So let's after that, we have successfully compiled our code. I'll just revert it back to the normal size. So successfully compiled our code. We can move on and deploy it to a blockchain simulation. Okay, so let's go ahead and see how we can do that. For the first example, we'll be using a simulation provided by the Remix ID called JavaScript VM. Do not confuse it with the JVM, Java Virtual Machine. It's a simple virtual machine of the simulation of the node. Nothing too fancy like Ganache or something like that. So over the left side, you have an icon that has a symbol of Ethereum alongside an arrow. So it's called a deploy and run transaction tab. Go to that tab, and there also we have some settings. Let's go through them one by one. So here you have the first option is to select the environment. So yeah, the JavaScript VM, injected Web3 and Web3 product. These are the three options that we have. So let's see what are those. The first one is JavaScript VM. These are that's a simple simulation provided by an execution environment to simply manually test or something like provided by the Remix ID. Then we have injected Web3. That is the way in which if you want to connect to MetaMask, values like MetaMask using Remix, then you can use the injected Web3 option. And Web3 provider can be used to connect to an actual Ethereum node that is running on your computer or on any other remote computer, or you can use it to connect to Ganache, some simulator. I mean, if you have a simulators of Ethereum node, then you can also use that to connect to Web3 provider if that simulator provides that functionality. Ganache offers that. So for the first example, we'll see how we can do that using JavaScript VM. The JavaScript VM will provide us with like almost like more than 10, or I think 10 external loan accounts so that we can interact with the smart contract, and it will be pre-funded with 100 Ether each. Then we can specify the gas limit for the particular transaction. That means I am willing to spend this much gas cost for this much Ether. So it is specified in way, which is the smallest denomination of Ether. So I am willing to spend this much of gas or way for executing the following particular transaction. I'm not going to spend an additional penny on this. So you can specify that here. And if you want to send Ether to the contract alongside a transaction, then you can specify it over here. You can either specify it in way, giveaway, penny, or Ether. Then to make sure that you have compiled the compiled contract will be shown over here. In case if you have multiple contracts, like for example, multiple contract in the same file, then that will be listed over here also. So you can choose which contract you want to deploy. So in our case, it will be hello world. I'll just remove this. You don't really need that. So deploy the hello world. At the same time, you can also use the publish to IPFS option. It's the same as this option. So nothing changes there. Then deploy. You can just simply deploy the contract. And if everything goes all right, on the right side in the bottom, you can see there is a logging mechanism. And this is the log for the transaction that we just did. And if we explore that, you can see the status. One second. Status of the transaction, the unique hash of that particular transaction. It's a contract. It's a contract deployment transaction. That is why it is showing the contract address. Then who deployed the contract? The address of the party that deployed the contract, which will be this address. As you can see, 5BC4. Yeah. Then we have the gas limit. The transaction execution costs are not particularly correct because of it is shown in the JavaScript VM. Then the hash of the code and all the particular data related to that. This is where we can see if the transaction contained any Ether transaction. So always know that every action regarding Ether is taken out in as way inside the Ethereum virtual machine. So yeah, so we have successfully deployed our contract, and yeah, so there is no error. We have deployed it, and if we have successfully deployed it, then under the deployed contract section, the deploy and run transaction section, if you scroll down, under the deployed contract section, you can see the deployed contract, and you can actually interact with the public functions inside that contract. So over here, you can see as you can see, so we had two functions, right? See the getter function for the message, which is automatically created by the compiler, and the get message function that we defined. So let's execute both of them. Both of them will return the value of the message, which is hello world and some symbols. So let's click get message. As you can see, it has returned hello world and message is returned hello world. So in our case, get message has a difference because we labeled the return value. Other than that, everything else will be same. You just so I have a query in the chat. He's not able to see the deploy function. So we shall just scroll down to the transaction. I mean, you have to click on the expand symbol. So in the deployed contracts, click on this symbol and it will automatically expand. I just forgot to mention that. Are you still not able to see it?
So after deploying,
that
get message is not displayed.
That might be due to the fact that the remix ID might have been crashed or something like that. Just refresh the remix ID and perform the same actions. I mean, compile it and try to deploy it again.
Okay, again.
Yeah, I mean,
sometimes
that's a problem. Yeah.
Okay, I will.
So guys, the remix, I mean, if you have a good performing machines like 8 GB RAM, then you can directly go ahead and install Docker. And I mean, the safest or the easiest way to install a remix locally is to use the Docker container versions. You can do that by simply going to remix GitHub. If you want to host the remix ID on your, sorry, this is the wrong one, on your local computer, you can just go to this location, this site, and under the okay, that's too much scrolling speed. Yeah, so if you want to, you can either directly use the environment and then directly install it, but the better way is to use the Docker. It's a containerization mechanism. You can directly pull and host over here. So if you want to pursue this further, you can use this as a reference, and at that time, these kind of errors might be very less. So yeah, now let's go ahead and try with another program, in this program, we will be storing a number and retrieving that number. So this is one of the default programs provided by the Remix ID. I just removed the comments and said that.
Sir, can you explain us deploying in MetaMask?
Yeah, I mean, it will be, it is part of the session. It will be coming up in next, in the afternoon session actually.
Oh, thank you.
So yeah, I mean, we will be exploring all of this environment. I mean, we have 3 environments, right? We'll be exploring how we can connect using all of these 3 environments, but that will be in the afternoon section. So in this session, we'll be like ending with the JavaScript VM. So yeah, I'll just also one more time demonstrate how we can do this. First, code your program. So this program is about a function called storage. We have a state variable of the type uint. This is what I have mentioned. So in uint, we can specify uint 256, like starting from 8, uint 8 to uint 256 with a step increment of 8, and you can specify how much number or space of a specific variable. For other variables, it is also possible. But for string bytes, some other dynamic variables, it's not possible. So those kind of variables has to be marked with memory when passing as a function argument. So here I have a function called store, which intakes a uint variable called num, and I am storing that variable to the number state variable, and I am using another function to retrieve that particular variable. So after you have written your code, you can go directly to the compiler tab, configure your settings, and then compile it. And if the compilation is successful, you can see all the details. You can see the API details and bytecodes. Then go ahead and select the appropriate accounts you want, then deploy it. And under the deployed section, you can see all the details. You can store a number. I mean, in case if the function has an input and it is of the this is the default mutability function. In case of default, we won't be using any keywords to annote that, but this is the default immutability function. So in that case, Remix will differentiate it by using colors. So the blue, like dark blue, is used when it won't affect the state of the chain. It just reads from the chain, and the orange is indicated that it will be writing or it's changing the state of the block. So I'll just store it and we can retrieve. So this is how simply do a smart contract. We can we have this is the entire content for the first session. In the next session, we'll be going much deeper into using MetaMask, Ganache, all those things. But yeah, we can go into the question and answer session. Yeah, we can give any, I mean, all these things. I mean, apart from the keywords like contract, uint, all those things, those are system defined or the solidly defined ones. Others like the contract name, variable name, function name, are like we can give anything like that. Just follow the normal conventions from other languages. Other than that, there is nothing particularly special for it. So if you guys have any other question, we can start going to the question answering session. Okay, so in the afternoon, oh, okay, Vishal asked about the gas limit. So I'll just simply explain it. So gas limit means the limit of there are two kind of gas limits actually. There are gas limit for a transaction. I mean, as you know, the one of the main feature of the EVM is isolation. Sorry, terminability. That means you should be able to terminate any process that is happening within the EVM. And to implement that, we have something called either, and for any process, there will be a corresponding either value. I mean, it is always specified in way. So there, for example, add operation will have like three gas, and pop operation will have four values. So something like that. So in this kind of things, you have a particular operation. When performing a particular operation, the ether will be consumed, and you can specify how much ether for that particular action or particular transaction you can consume. So that is the gas limit.
അറിയില്ല വിളിച്ചു നോക്കിയോ അല്ല ഇന്നുണ്ടെന്ന് തോന്നുന്നു ഇന്നുമായിട്ടെന്നാ പറഞ്ഞത്.
Okay, so any other queries? Okay, then thank you for your patience. We can in the afternoon session we can start exploring MetaMask and Ganache, and how the interaction between the Remix, Ganache, MetaMask, or MetaMask, Ganache, and all those works out.
Okay. So we'll come back.
Sir, one question.
Okay. Yes, tell me.
So, can you tell me the difference between this, what we have done with the Remix, and what is the difference with the MetaMask?
I mean, the actions will be the same. I mean, coding will be the same. MetaMask is a wallet, a light wallet, which can be used to communicate with the Ethereum network. It's two different components.
Okay.
I will show you it in the afternoon session, then it will be clearer.
Okay, sir. Okay, sir. Thank you.
Okay, sir. Then we will stop here and come back at 2 o'clock.
Okay. Okay. Thank you, everyone.
Okay. Thank you. സൈൻ ചെയ്യാൻ ഞാനല്ല. അറിയില്ല. So we can continue, I think. Next section we will continue. Hello? Another hello?
Yeah, okay, we can
We will
continue.
start.
Okay, so I hope everyone is able to see my screen. Okay, so I'll just demonstrate one more smart contract. Then we can move on how we can deploy that to the main Ethereum network, not the main Ethereum network, to one of the test Ethereum networks like Robston or Rinkeby. Okay, so yeah. So I have already coded up the code. So just like I said in the morning session, this code or this smart contract is used to store details regarding a student's project submission actually. So enum is, first let me explain the smart contract in detail. So I have a contract called student details, and in which I have a user defined variable called faces, which is defined using the enum data type. So basically using enum, we can make the code more readable. That is because the actual value of these are like starts from 1 is corresponding to 0, 1 and 2. So basically it's just integer, but we can make the code more readable. And enum can be used to represent multi-state. Like Boolean can be only used to represent binary state, but enum can be used to represent multi-state. Then we have structure, which is also another data type which we can use to create user-defined variables. So here I am creating a struct called student, and which will have the members such as a name, which is of the type a string, project name, project description, project URL, and the submission status of the current phase and the which phase in which the project is. Then as I've said before, mapping, which is a key value pair. I'm creating a mapping between a uint. So basically the project will have an ID or a student will have an ID. And for each corresponding ID, we will have a struct. So basically for each corresponding integer, there will be a student which has these minimum base. And I have set this as private because I don't really want anyone else having access to that. So this contract only will have the access. Then I am having another function called set student, and it has arguments such as an ID, then name, a project name, project detail, all the details necessary for the submission. And this is how you add value to a mapping. So you specify the name of the value, a mapping, and specify the key. So mapping is a key value pair. So you specify the key, then adding a value to a struct, you can just simply specify a member of that struct, so dot name. So here it is dot name, project name, and you just pass in the values. Then moving on, we have another function to get the value. So just like we passed in the value, this is how we get the value from struct mapping. So yeah, in most of the scenarios, we will be using a combination of struct and mapping whenever we want to go through like storing and all those things. This is a simple, like just you can compare it with a simple KYC of a bank application. It's a simple way in which you can store many details regarding a student. I just start compiling it, and yeah, it's already compiled. Yes, it's already compiled. I'll just push it on the IPFS and just give you guys a code. Okay, so Where was the chat? Okay, so the code is available at this link. You can go ahead and execute that. So there isn't much. We are just simply storing the name, project description, project URL, and the submission status and project state of the project's phase state of a student. I mean, we can store multiple students. So yeah. So do anyone has any doubts regarding the previous sessions? If we have a doubt, we can discuss that. Otherwise, we can like see how we can deploy this contract to the Ethereum test network. One of the test networks, I think, are Robston. Test networks are like constantly maintained, and I just to be I forgot to mention that in the remix ID, these files, these artifacts are generated as part of the compilation, and these things are generated as part of publishing to the IPFS. These files are actually stored inside the browser memory. So if you clear the cache of the remix site or clear the cache of the browser entirely, these will be long gone. So either you can publish them to IPFS, but that will be like only there if you maintain your own node. But or you can like GitHub provides us with a facility to store code snippets, so you can use that option, like publish your code to the GitHub, or you can simply copy all these codes and open a notepad, then paste it over there. Yeah. So that's one way of doing that. And yes, so make sure that you always save your progress. Otherwise, if you just put it in the remix ID, you might lose it. So be always mindful about that. Yeah. Okay. Now let's see how we can connect to MetaMask and configure all those things. So I just I already have MetaMask installed, but I'll just remove that and start from the scratch. Okay. To install MetaMask, go to metamask.io. So I'll just put that in the chat. Go to metamask.io and click on the download button, and it will automatically detect which browser you are using.
Excuse me, sir.
Yeah, tell me.
Actually, we already downloaded this MetaMask.
Okay, so everyone is downloaded?
Yesterday also there was hands-on.
Oh, okay. In that case, I'll just skip that part. So I removed, so I'll just install that. Okay. So yeah, so you guys are also configured, right? So anyway, I'll just explain it as I go through it. So get started. If you already have a wallet, you can use the secret seed phrase. Otherwise, you can create a new one. So I don't really have one currently. A seed phrase currently with me, so I just create new wallet. Agree to their conditions. Give it a password for the wallet. It's not for the accounts, it's for the wallet. So give it a password. If you agree with the terms of use, tick that and continue. So yeah, this is a seed phrase. So you might know, but I just explained it again. So basically, MetaMask is a hierarchical deterministic wallet. That means the key generation. When we use the key generation algorithm for Ethereum, what we does is that we create, we choose a random value. We somehow generate a random value. I mean, there are different mechanisms. Some capture the moment of my mouse movement. So like this moment, some might capture the coordinates for the mouse moment and create that as a random value. Then from that random value, we'll create a private key. Then from that private key, we'll create a public key. and then that public key is actually hashed using kekak or sha, then the address is generated. So that's how the flow goes. So in the case of hierarchical deterministic wallet, they use this seed phrase as that random value, and at the end they add, for example, at the end they add a constant value, for example 1, 2, 3, and they increment that value and generate address based on that. So using a single value, we can generate back up all those address. So yeah, that's why we use the secret phrase, backup phrase for MetaMask, and also Ganache follows the same mechanism. Okay, so we'll move on. Just need to confirm the secret passphrase. Ginger. Okay, so I have successfully completed this. Okay, so now that we have successfully configured the MetaMask, let's connect it to the Robson network. So go to the networks option, switch to Robson test network. Now we need to get some test either, so that we can deploy this contract to the MetaMask network. So yeah, sorry, to the Robson network. So let's get some test either for the Robson network. To do that, click on the buy icon, the buy icon over here. So I mean, there are buy and send. So click on the buy icon, and there are like two options: directly deposit either. For that, we need to have someone else deposit that, but we don't have someone like that. But for due to the fact this is a test network, we can just simply use the test faucet and click on the get either. It will redirect you to MetaMask faucet. I mean, faucet is the sites that normally give you test ethers. So request some ethers from the faucet site. Per IP basis, I mean, due to the spam and due to avoiding spam, there is an IP restriction. So from an IP, you can, so when you click request one ether from faucet, you need to confirm your communication with the site. So from MetaMask, this is a security mechanism provided by the MetaMask. You have to confirm permission. I mean, give permission to this particular site to access the first account. So I'm just giving it permission. I'll click next and click connect. So after the connection is established, yeah, I think the faucet is having some problems. Okay, so let me just check what's the problem. Okay, so switching back and connecting to Rockstar testing tool. Just faucet connect. Yeah, it looks like there is some problem with the MetaMask faucet. Let me check for the other faucet. So yeah. Let's see. I mean, there are multiple faucets for a same test network. Let's see if this works. If it didn't work, we can go and like try to connect with another network. So to copy your address, you can just click on this icon over here, and it will be copied to your clipboard. Okay, so it will take some time to process, and as long as it is processed, you can see it over here. Okay, so let's go ahead and connect MetaMask to Remix. I mean, in that time period, it will be populated. So let's go ahead and connect Remix to MetaMask. So select your Remix ID. Make sure your code, whichever code you want to deploy, is compiled, and switch to deploy and run transactions. Over there, we all earlier used the JavaScript VM environment. Instead of that, we'll be using the injected web. If you click on that, okay, 1 second. Seems like the Remix has some problem. Okay, so injected web3, yeah. Sometimes Remix lately Remix has been crashing. So yeah, so when you select the injected web3 option, it will automatically send a connection request to MetaMask, requesting for this site to access the MetaMask. So you just need to accept it, just like for the faucet. So accept that. And as you can see, we have connected, established connection with the Robson test network. You can see the ID over here, and it has recognized it as Robson test network. You can see the account that is available, or that we just connected. As you can see, let's just check. So it starts with the 4C and end with the 303. So yeah, my request has been accepted by the faucet. So I currently have 5 Ether, which is more than enough for our lab. So the balance can also be seen over here. So after connecting to the injected Web3, go ahead and compile your contract. Yeah, so auto compile is enabled, so it's already compiled. Then click on the deploy button. At that time, I mean, whenever we do a transaction in Ethereum network, it requires a gas fee. So at that time, you can see the gas fee necessary for it, and the gas price. I mean, the MetaMask will give you an average gas price for the network, and this will be the total amount that you need to pay. So you need to confirm your payment. It will take some time. If you click on the MetaMask, you can see the contract deployment process. Yeah, I think, yeah, it has been completed. If you check on that, you can see the transaction logs. And also, if you just click on this created with value, I mean, any of the transaction logs, you can simply go to either scan and see much more detailed report about that. So yeah, I think I have something in the chat. Okay, so how much money I have left? Okay, so I'll show you again how we can connect your MetaMask to Remix. So let's just go ahead and do that. So let's just reset it. So just go back to JavaScript VM, or you can just simply refresh it. Okay. Now select your contract that you want to deploy. Make sure it is compiled and ready. And then go to deploy and run transactions. Select injected web3 under environment section. So you need to select this injected web3. So select that. And I mean, I already established connection with the MetaMask before, that's why it didn't show the confirmation. So I'll just reset that too. If you go to MetaMask, you can see this connected. You can see if you click on this connect, I mean, you see this small icon, right? I mean, I'll just show you it in an extended form. Expanded view. Oh, it looks like the expanded view doesn't have it. So I'm sorry about that. So if you click on the connected on the left side, when you are in the site corresponding, whichever site you are connected. So click on that and you can see to which account the Remix Ethereum is connected. So if I just remove that, we can just start from the beginning actually. So you under the environment section, click the injected web3, confirm your connection to the corresponding account. connect. Yes, we have connect. Now we have established connection with whichever network the MetaMask is currently connected to. As you can see, the MetaMask is currently connected to the Robston test network. So yeah, the injected Web3 is connected, and it also the remix itself also recognized the connected test network. So we can go ahead and deploy that. So it also listed, the remix also listed the permitted. So didn't have multiple accounts over here, but if you have multiple accounts over here, when you connect, for example, if you disconnect, I can just simply create a new account, create an account. I mean, in the accounts menu, in the my accounts menu, you can go to and create an account and just simply create a new one. I just go switch back to the old one, but anyway. So now we are not connected to remix, but yeah, if we try to connect, you see, we can select which account we want to establish connection to. So whichever account we have selected, it will be listed over here as part of our. Now, so access to that accounts. Now, if we switch over here, switch the accounts over here, it will be able to connect to that account. But switching that account might trigger the remix to reload, so I'm not doing that. Have some queries, I think. Vishal, do you have a necessary test either in your account for doing the transaction? Check if you have the necessary balance. It might be due to the fact that you are not having enough balance. Okay, so after establishing connection, you can go ahead and check your balance. I mean, in the selected account. Remix will be showing the selected account in the MetaMask. For example, if I switch to this one, it will show the other account. So it has 0 either, but I'll just switch back to the other account so that we can deploy. Yeah. So it has 4.9. I mean, I deployed it before, so that way one either is missing. So if you go back and then press deploy again, the MetaMask will confirm your. MetaMask will confirm. Okay, so the MetaMask will confirm your total gas that you are willing to spend and confirm that. Wait for some second. The remix also shows you the log for that. If you click on that, you will be redirected to Robston test network, and you can see the status of the transaction. As you can see, it is pending, and it will take some time. You can also see the same thing inside the MetaMask. As you can see, the activity is pending and it is in queue. Yeah. So whenever you complete, you can see the complete log. So. Now, after it is deployed, everything is same as we dealt with the JavaScript VM. We can see we have under the deployed contract section, we can see the corresponding buttons and all those things. We have two functions, set student, one to populate the values, and we have another get student. So it looks like the remix also updated its, Ethers can also update its status. As you can see, this is our transaction it's a contract, and it's committed on this block, and we have 4 block confirmations. I mean, after this block, we have 4 blocks that's confirmed. Now let's just add some values. So I'll just use 3001 name. For the QRL, so to input values to Boolean, you can either provide true or false. And in case of enum, it's also always considered as uin. So you can go ahead and if it is phase 1, you can provide 0. If it is phase 2, 1. Sorry, phase 1, then 2. Yeah, phase 2, then 1. Phase 3, then 2. So that's the value for enum is. So yeah, if I transact the value, yeah. So I think I have given a false value in any one of the, is it? Yeah, see u in date. So I just provide with the 1. So for the same, I mean, we are doing a state change. So in that state change also, we'll need to confirm our writing, and this much will be the fee that we need to write this transaction. Let's confirm that. Yeah, Vishal, you need to get a ether for your account actually. I mean, I'll show you again how we can get test ether. So go to this site, faucet.dimension.network. So go to this site. I'll just refresh it there because I already have the request. And then copy your address from MetaMask to whichever account you want to add Ether. So by like selecting, if you want to add this to this account, select that account, then click on the account, I mean name of the account and the address. Then the account will be automatically copied to your clipboard. Go back to your site, paste your address over here, then send a Robston it. So for me, I already have requested from this IP, so I can only request after 24 hours, but for you guys, you will be able to request 5 Ether. So it will take some time for like for five or 4 minutes. For me, I think it will take 2 or 3 minutes. So wait for that to populate either, and after you go back, you can, I mean, after some time when you go back, you'll see the status over here also. So you can go back and see, see, I have already received the Ether and I can see the status over here. So when you receive the Ether, it will be displayed over here, so you can get the details regarding that. Okay, so let's just check if our right information has been completed. Yeah. So my I have stored details regarding the student. So let's just try retrieving that. The student ID I have provided is 1. So let's just use 1 and get student details. So as you can see, all the stored details has been retrieved successfully. So this is how we can deploy a contract into the Ethereum main network test. I mean, the procedure is exactly the same for deploying to the main network. The only problem is that we have to need Ether for the main Ethereum network. Otherwise, there is no other requirement. You can do a normal contract deployment for the normal or your actual contract deployment for the main network if you have the necessary Ether. So yeah. Why don't you guys like take 5 or 10 minutes and do check it out how we can do this entire procedure, and if you have any doubt you can just go ahead and ask. Sushil, I'm not presenting right now. I have given you guys a 5 minutes interval so that you guys can try out what I just did now. And if you guys have any doubts, then you can ask while you are trying out, or just take 5 minutes and do it. I mean, it's better always to do it right now rather than doing it later by looking at the recordings, because you might encounter some unknown errors. I mean, it's not uncommon to encounter the errors that even I don't know. So yeah, just take. We'll go to the next session, 2:35. Also, just a quick reminder: if you guys want to populate, connect to another network, you can. Each and every network has their own faucet. I don't really want to reload now. So connect to any network and click buy, and you'll have a faucet for the test networks. So any network is okay. So if you guys are like, if all of you are like accessing from the college network or something like that, then so I mean, the site is working perfectly fine for me. That means you might be having an internet issue. Oh yeah, seems like the site went down. No, it's working fine. So basically, if you want to create a new account, you can simply, I mean, there is a DP right over here, like on the right side of the networks menu. Click on that symbol, and if you want to create a new account, under my accounts menu, there is an option called create account, and you simply click that and provide your account and a name, then create it. Now you have I have three accounts, and I can like seamlessly switch between them. I'm connected to the option, so that's why I didn't have any mind. So yeah, each and every network will have different authorization mechanism for the faucet. Like Robson doesn't really have any authorization mechanism. For Coven, I think you have to have a GitHub or GitLab account if you want to you add either. Or for Ringaby, I think you need to post a tweet or a Facebook post to get the corresponding ether. So yeah, it's different, but it's simple. You can go with it. Robson has the simplest mechanism of acquiring ether. So if it says limit reached or something like that, that means someone from your network, if you are using Wi-Fi or college Wi-Fi or your own Wi-Fi, someone accessed this site and request ether from this site. That's why you are not getting it. So if you just I have some excess ether over here. So if you want either, you can just, not everyone, but if someone is not getting either in any way, you can just provide me with your address and I can send you some either. So Vishal, if you didn't get some either, you can just put your address over here so I can send you some either. Your Ethereum address, Vishal, not the Gmail address. If you click on this icon, you can just simply get that. And so if you want to send either to another account, you can simply click the send option. So I'll be able to demonstrate this. So simply click the send option, paste your address over there, and if it is a valid address, it will click a tick mark, and after that it will show your balance. So I have 4.9 ether balance, so I'll just send 0.5 ether, and this will be the gas price and gas limit I'll be requiring. So I don't think that much is, yeah. I just provided that, and next, confirm. And when this transaction finishes, who sent me that address? Okay, so yeah, I think Dr. Durga Karthik sent me the address. So yeah,
Yes,
Durga,
sir.
please check your.
Yes, sir. I'm just checking. 1 second, sir.
Yeah, I have sent you 4.5 either, and that will be enough for this lab actually.
Yes, sir. 0.5 received. Thank you.
Okay.
And I also received 5 ethers, sir. Sorry. Only now I
Okay,
have received it. Thank you.
no problem. Okay.
Yes,
So
sir. Thank you.
yeah. So Vishal, I'll also send you 4.5. So to send some either to another part, you can just simply go click send, then paste the account. If the address is not valid, like if there is a space or an extra number is added, then it won't detect. But if it's the correct address, then I mean only the format, not the correct address. If the format is correct, then it will automatically detect, show your balance, and so I just sent you some ether. Yeah, okay, so as soon as it's finished sending, you will get your ether. So if anyone else, let's see if anyone else requested. Okay, so we shall please check your account. 0.5 might have been credited to your account. Yeah. Okay. So if everyone has completed the exercise, you can move to the next one. Okay, so those who just received the ether can carry on with the testing. So the next is about Ganache, which is a simulated blockchain actually. A simulated blockchain and blockchain node, not the blockchain network, entire network, because if we have multiple nodes, then that will connect with each other, and then we will form a network. So currently, for those people or like people like us who are the developers in the Ethereum world and want to have an Ethereum node so that we can test out our development and all those things. And in that case, like we'll be opening multiple applications at the same time. We will be handling IDs, Visual Studio Code, multiple windows. So in that time, we might not be able to spare 6 GB of 6 GB of memory in the RAM. Like we'll be researching so much time, so many things in the tabs, and all those things will be there. So we won't be able to provide or free up that much memory. But in that case, we won't be able to run a full Ethereum node. So instead of doing that, we can install a simulation called Ganache, and it gives you the same output. Whatever input you give to a normal Ethereum node, Ganache will give you the same output. It will react in the same way as an actual Ethereum node, but in our case, we won't be needing to do any mining or any proof of work mechanism. So it is not resource intensive. So we can just simply develop and do our own thing. Okay. So I think pretty much everyone has checked it. So if anyone has doubt regarding the previous session, you guys can just put that in the chat and I will address that. So let's move on and create Ganache. So go to truffle.com/Ganache. Actually, it's better like click on the need another OS download. So it's always better. Select the first one, 2.54 I mean, Johnny Cake is it's a name provided for that particular version. So I'll just put this link in the chat. So I have also already downloaded this and share it with the institute. I mean, you guys might have received a drive link. So you guys, if you guys haven't already installed it, you can go simply download. For Windows, I think I prefer always downloading the exe file. I mean the the apx. Yeah, where's the apx? Yeah, appx is Windows like Metro style applications, like these kind of applications, like these inbuilt applications are all of the appx extension. I prefer going with the Windows setup.exe because it's much smaller than the I'm thinking, yeah, appx file. So you can, for Windows guys, go with the .exe. For Mac, there is a Mac DMG or zip file. For Linux, just simply download it and double click and you will be able to install it. Yeah, so if you guys have already installed it, then just install that, or you can go ahead and download it and install it. So just put it for downloading, and it's a simple application. Installation is not that not that very complicated. Yeah, Sandeep sir also have already provided the drive link. So it is preferable if you download from the drive, because the server where the Ganache is hosted, I mean the downloading from the GitHub will take too much time if you don't have a pretty good internet connection. But from downloading from drive, it is different. So you guys can go ahead and download from the drive. I mean, I myself prefer from downloading from a Google Drive location. So anyway, this is the place if you want to try out the different versions of, or if you want to get the source code of Ganache, and then you can go right ahead and get it from here. For this lab, we'll be using the 2.54 version. They have like fixed most of the errors. Like the previous version sometimes crashes, so they have fixed that in this version. So if you have Ganache exe for Windows, I'll be able to demonstrate that. So yeah, if you have setup, just double click that and double click and follow the setup wizard. There is no complicated installation. Just click next, and you will be able to install that. Like simply click on the install, and you can specify the location you want to. I mean, you can go with the default version, but default location. But if you want to specify, you can specify. So I already have installed it. So I'll just launch it. So after installing in Windows, you can just type in Ganache in the start menu and simply open that. It takes some time. I mean, it's not that resource intensive, but to boot it up, it takes some time. So if you run, when you run the Ganache for the first time, you will be greeted with a window like this. So over here, you have two options. One is to start Ganache with the default settings provided by the developers. Another one is to configure your own workspace. So like the quick start environment will always reset whenever you like restart Ganache. But in case of new workspace, you will get a persistent workspace, like just like the quick start environment, but it will be persistent. I mean, any transaction you do to this environment will be retained unless or until you delete that workspace. So let's just go with the new workspace. Yeah, okay, so it will take some time. I mean, it didn't usually took this much time when it was in an older version, but as they are updating, and whenever they update it, the speed for booting it up increases. So as usual, your workspace can be given a name, and if you have any truffle projects, like the Ganache is part of the truffle framework. It's a framework that can be used to monitor the entire life cycle, like coding, compilation, deployment, and after calling, all those things can be monitored. Testing, all those things can be done in the truffle environment. But if you have a project relating to truffle, then you can add that over here. But we don't have one of those, so we'll move ahead. We'll just set a name for the workspace, the server. So where you will be hosting your node, and if you want to put it on all, like if you are on a Wi-Fi network and if you want your friend to access that, you can provide it on all internet network, or you can provide directly to your IP. So this is my IP on this Wi-Fi network, and you can provide it as a loopback. I mean the local host address. So I'll just host on the local host, so that for doing this lab, you can specify in which port we will be exposing, I mean the communication point. To communicate with an Ethereum node or a normal node, normally to an actual node we will have multiple options, but for this we'll have the RPC JSON, the HTTP protocol to access the Ganache. So we'll be hosting that protocol on 7545 port. And to uniquely identify each network, we will have a network ID. I mean, to each network, for main network it is 1, for Robson it is 3, Covenant 4 or 47, Ringaby 4 or 47. You guys can just Google it out and you will get that number. So to uniquely identify each network, we'll have a network ID. You can enable auto mine. I mean, there is no actual mining happening there, but whenever it detects a transaction, it will automatically commit it. That's why the auto mining. Then we can specify how much Ether our account want. Like if you want 1,000 Ether, you can specify that. How much account you want, and like you can specify your seed phrase. So in Ganache, it is called a mnemonic. Seed phrase, secret phrase, mnemonic, all are the same. According to different applications, the name changes. That's all. So you can specify your corresponding seed phrase over there. How many accounts you want, how many Ether on each account you want, and the chain, the gas limit for the entire blockchain, gas price for a particular blockchain, and which version of blockchain you want to simulate. So that is also selected. In the advanced section is just a logging. If you want to output the log to a specifier, then you can specify that log file. Unless you can just simply display it on the Ganache itself. If you want to provide support for the Ganache, then they will be able to, if you enable the Google Analytics, they'll be able to get your feedback whenever you use it. Then the next tab is just about the Ganache. So yeah, that's the entire configuration. So basically you can configure the name for your workspace, your server configuration, where you want to host it, your port, your network ID, the details regarding accounts, then details regarding the chain. So then after you have configured everything, just go ahead and save the workspace. Now this is the Ganache. This is the actual workspace we get with the Ganache, and it will have all the details. Like current block is 0. I mean, I can't zoom it on this one. That's why I can't zoom it. So the current block on the top bar, you can see that status regarding the blockchain, the current block, gas price, gas limit, which version we are using, network ID, where we are hosting this this application, and if the mining status is all or not, the name of the KB workspace. And if you have different workspace, you can use the switch. You can create a new and then switch back to that. If you want to delete a workspace, you can simply click that, or just select that and go back to the workspace. So on the above, we have different tabs. So the account tabs list out all the accounts. So we have 10 accounts with 1,000 Ethers each. We can just get the address. And if you look at the far end on the right corner, you can see a key symbol. And if you click on that key symbol, you can see the account and the private key is also there. So please keep this in mind, because when we do the MetaMask with the Ganache connection, we will need the private key to import that mechanism. Now let's go ahead and explore other tabs. we have blocks, which will show all the mined blocks. This is a Genesis block because we haven't done any transaction on this, so this is a Genesis block. You can see it was mined on 250, and this is a block hash, the gas limit and the gas use. So Genesis block, so there won't be any gas use. So any transactions, so the transaction is empty because we haven't done anything. The contract is only available if you have linked it to the truffle project. If you have any events in your contract, then the log. So everything will be shown here. Though, so it has been started, and yeah. Now let's do the first thing. Let's see how we can connect Ganache to Remix. So before that, so all of you have finished installing, right? I mean, is there anyone like if you are in the process of downloading or in the process of installing, there's no problem. If anyone encountered any error, please do let me know. Okay then. Okay then. So if you guys want to try this out, you guys can like take 5 minutes and try creating your own workspace and running the Ganache application. Then after that, we can connect to Remix. So just take 5 minutes and connect to configure your workspace. Like we'll get back at 2:55 or 56 or something like that. Okay, so of course, Niranjan, I'll just show you again how we can do this. So after you have, I'll just reset it to 0 so that we can do it. So after installing Ganache, just launch it. So I'll simply open Ganache. And when you're opening it for the first time, you will say that we have two options. Either is to use the quick start, in which case it will go with the default settings. And if you want to change the settings, you can use the new workspace. So click on the new workspace option. It will take some time to boot it up. So after it is enabled, you can provide a workspace name, KBA. So then configure the server where you want to host it. You can either give 00 so that it will be available on all interfaces, or you can directly host it to your Wi-Fi, only your Wi-Fi location. I mean, if you give 00, it will be available on localhost or Wi-Fi everywhere. So yeah, no, not all on localhost, but other interface. So yeah, if you have a Wi-Fi and you want your colleague to access, you can provide it on Wi-Fi or all interface. So I'll just go host on localhost. Specify a port number in which port you want to expose this node. I mean, like using which port we can communicate with this node. Specify a network ID, which is an unique ID used to uniquely identify the blockchain. I mean, so yeah, it's not really mandatory for a simulation, but we can specify that. Then after that, you can turn on the auto mine, show error on transaction failure, all those things. Then you can specify details regarding the account. If you want to have 1,000 or more than that either, you can specify that, how many accounts you want. Let's just set it to 5. Then you can specify your own mnemonic or seed phrase. It's just a tolerated word. You can specify 12 individual words and it will be considered as a mnemonic or a seed phrase or a secret backup phrase, anything. I mean, it hasn't too many names to remember. Then you can configure the chain. You can specify the gas limit for the chain, gas price, and which version you are of Ethereum client you want to use. Then logging functionalities, analytics, effort. Then you can go ahead and if you have finished setting up your workspace, you can go ahead and save the workspace. And as you can see, the like each account has 10,000 ether, and I have only requested for 5 accounts to be populated. So there you have it. So that's why you set it up a new workspace. So I hope everyone did that. Okay, so let's go ahead. I hope everyone was successfully able to do that. Let's go ahead and connect Ganache to Remix. So make sure that the Ganache is up and running. Copy the RPC server address. So you can just double click over here and it will be copied. So Control C, press Control C, and it will be copied out from there. Now let's just see. Go back to Remix ID. Disconnect from MetaMask. You can just choose any other environment. So for connecting to Ganache or connecting to an actual Ethereum node, you can use the Web3 provider option. So under the environment, select Web3 provider. Environment, Web3 provider, and yeah, you will get a big pop-up. In the bottom, at the very bottom, there is an input box named Web3 provider endpoint. Paste your URL over there. So it was like HTTP 120 localhost address 7545. Then paste your URL over here. Then click OK. So as you can see, we have connected with the Ganache, and it is showing the network ID. I mean, our network ID was 5777. It is showing over there. And then we can explore all the accounts available in Ganache also. So that's how we connect with the Ganache. After that, everything is same. We can just deploy. I mean, it will be just quicker than deploying to an actual test network. So we can do everything the same as we did with the JVM or like with the MetaMask also. So yeah. So if you guys got all of that, then I can also show you guys how, I mean, how we can connect with the MetaMask to Ganache. Like if you in some cases, if there are necessary, like if you are providing MetaMask as a front end to your D app, then you should be able to test MetaMask, and instead of connecting that to your actual test network, I mean, you have seen how much time it takes to do a transaction in the test network. So instead of that, you can use the Ganache. So in that time, if you want to like your D app, then MetaMask and a blockchain network. If you want to test that flow, then you can connect your MetaMask directly to your Ganache, then test that flow. So it will be easier, and you'll have much better experience, and you'll be able to explore all the details. See, as you can see in Ganache, if you go back to Ganache after deploying a contract, you can see the contract creation. All those details will be there. It will be easier to explore the Ganache because Ganache will show you all the details regarding your transactions. All will be there. It will be easier if you work with Ganache rather than the JVM or the actual node. Even the actual node only has a command line interface. Only Ganache has a GUI interface. So if you want to have a smooth operation, then you should go with this. Only in case of development, after you have like thoroughly developed it, you should go for the create a custom network yourself, test on the test network, then deploy on the main network. I mean, before do the auditing and unit testing, all those things. So yeah, that's how you connect with the Web3 with Ganache. Simply, simply clicking on the Web3 provider and specifying the endpoint. That's all. And it will connect and automatically populate all the addresses we had. Okay, so to connect with Ganache, make sure that your Ganache is up and running. Copy the RPC server URL. Then go back to Remix. Choose the third option, Web3 provider. Paste your RPC server URL there and click OK. Now you have established connection. Yeah, so Vishal, did you get that? Okay, so if you you guys can take 2 minutes, 2 to 5 minutes, and try connecting with the Ganache and deploying your, yeah. Okay, so I think most of the people have finished doing it. Then I will just wait for 2 minutes so that others can do it too. So. Okay, I mean, this process didn't really take that much time. So we can move on and see how we can connect MetaMask to Ganache. So as you know, both of them share the same wallet mechanism, like Ganache and MetaMask uses a mnemonic or seed phrase, or I mean, whichever you want to call it, seed phrase to create accounts. So, wait a second, I think I have an echo read. Okay, so everything is done. Okay, so the first step is to copy the mnemonic. So just come to Ganache, double click over here. Yeah, so click from there, and so you can simply click on this icon, I mean the account icon, then lock your account. Lock the MetaMask, and at that time you'll be seeing this import using account seed phrase. So after if you are logged into your wallet, you can see log out from it, lock it, and you can see import account using seed phrase. So we'll be importing a wallet. So import account using seed phrase. Click on that. Provide your wallet seed. So it's the same as it's provided over here. You just need to copy it from here. So copy it from there. Paste it over here. I mean, if you click the show seed phrase, then you can see that there. Provide a new password for your wallet, because we'll be entirely creating a new wallet over here. So I'll just provide a random value. So remember, do not remove the old seed phrase, or you might regret doing that. Like, I mean, you already had some ether, right? So in any case, if you forgot to save your ether, you can just go back I'm just showing this in any case if you forgot to save the old seed phrase. So if you can go back and go to the settings, click on this My Accounts menu like this in this Smart DP, click Settings, go to Security and Privacy. I mean, we have many settings over here, but the important one is Security and Privacy, and you can see the Reveal Seed Phrase over here. You click on that and provide your password. Enter, and you can see the seed phrase, and I'll just copy. I'll just copy that and store some. Okay, now that we are ready, we can go ahead and copy the mnemonics of the Ganache. Then go back to MetaMask, lock it, import using account. Sorry, go using seed phrase. Paste your seed phrase. Provide it with a new password. Then restore it. So as you can see, the account is there. I mean, let's check if it is the correct one. So what is the first account of Ganache? It starts with the C and ends with the 70. Yeah, so we got the account. So why it is 0? Curious, right? I mean, the problem is that we are not connected to Ganache. We are connected to Robson Test Network and we just have an account, but we are not connected to Ganache. So to connect with Ganache, to establish connection with Ganache, we already have like 1, 2, 3, 4, 5, 6 profiles to connect to a particular pre-configured profiles to connect to a particular network. So instead of that, we need to create a new profile to connect to Ganache. To do that, open the networks menu. This menu is called the networks menu. You already have profiles for Ethereum, Robson, Coven, Gabigoril, and localhost. So click on the custom RPC option. So in the networks menu, click on the custom RPC option. Click on it, and here you have to provide it with a name, your RPC URL. So I mean, I previously populated it that way. It is populating it back. So name, you can provide any name. It's just a profile name for the networks in MetaMask. RPC URL, you can get that from here, like the RPC server URL. It's the same when we used it at PMix, so you can use that. The chain ID, I mean, the chain ID of this one is actually kind of I forgot that, and it's not 5777. I actually can simply provide a false value. To get the chain ID, you can simply provide a false value over there, and it will give you the chain ID. So this is a chain ID. It's shown in big number value. So simply provide a false value over here, some false value, and it will provide us with the chain ID. I mean, it is not listed over in the Ganache. I mean, it's part of a new update to the MetaMask. That's why, I mean, the chain ID was optional previously. I mean, up until yesterday, it was optional. Today, it is yesterday evening, it went to mandatory from optional. Yeah.
No, sir, it is optional. Optional.
Yeah.
Chain ID is optional.
So, you guys installed the MetaMask yesterday, right?
Okay.
So
yes.
if you update, then it will go to from optional to this version. Actually, I mean, I actually not accidentally I update it free on a daily basis, so that's why it is not optional for me anyway.
Okay.
Okay. So after you provide the chain ID, I mean,
So
if it is optional for you guys, you don't need to provide the chain ID. But in case if it is not optional for you, you can just randomly provide a number and click save, and you will get the chain ID from the warning message. So provide the chain ID, click save, and nothing will happen actually. I mean, you can just go back and close the settings. I mean, after you save, you can see on the left side, there is a new network profile. So just go back and close the settings, and you can see we have the ether. So it's a corresponding same amount of ether we have on our account. So you might be thinking, we only have one account, right? I mean, the Ganache listing is listing out 5 accounts, but we only have one of them here. So there is two mechanism in which we can import the second or the other accounts. So the first mechanism is to import using the private key. So let's get the private key of the second account. To get that, go back to Ganache, and this is the second account, right? I mean, I have some query at least. Okay, so for those who are optional, you don't need to give the chain ID. Okay, so this is the second account. Click the key symbol on the right side, and under the private key, copy the private key using Control C. Copy the private key, and after copying the private key, sorry, I just overwrite the private key. So yeah, copy the private key. Go back to MetaMask. Use the import account function. So under the, I'll just cancel and show it again. Under the My Accounts menu options, under the Create Account, use the Import Account. Select the Import Account option. Paste your private key. So like, yeah, this is where you paste your private key and click Import. So the second account has been imported. So this is how we can one of the main mechanism in which you can import your account. Get your rest of the payment. So if you repeat this process, you can get the rest of the accounts. But there is also another mechanism in which you can get the accounts, because the fact that both of these accounts follows, both of these mechanism follows the deterministic hierarchical deterministic valid mechanism. It will be incrementing a constant number when each time we create a new account. That means until the fifth index, we already have 5 accounts until the fifth index. So until the fifth index, we will be having populated address. So let's try creating one account. So account 3, create. We got the third account, right? Oh yeah. So the problem is that we already imported the second account, but whenever we create it, it will be coming at the same one. We imported one, but the MetaMask counter doesn't increment when we do the import option. So we created a new account. We will create it again. It will be like 6AF0. Let's see, 6AF0. We got the third account, and if we continue this option until like the fifth account, I'll just do that. Yeah, create a new account, create account, create. So until the fifth one, we won't be will be having the ethers, because we have 5 accounts, and all of those are populated with 1,000 ethers. So whenever we create a new one, which is not populated with the ether, it will. I'll just create the 6th account. It will be empty. So this is how the hierarchical deterministic valid works. Both are compatible with each other. That's why we were able to get the accounts back. So yeah, whenever, like for example, you have 3 accounts related to a seed phrase. Whenever you import your account using the seed phrase, you have to do this mechanism if you have more than one account to retrieve those accounts. So yeah, that's how we can do these things. And if you guys go ahead and try this out. And one more thing is that now you can go directly to Integrate Web3, connect with the MetaMask. So I just select the first one, connection established. As you can see, when we use the Ganache and directly connected, it showed the 5777 network ID. And when we use the MetaMask, it also showed the 5777 network ID. Let's just looks like there is some error. Yeah, the selected account doesn't have any money. That's right. So I'll just select the first one. Yeah. So now let's go ahead and deploy one. So we'll be deploying this contract. It will be going through the MetaMask, but we'll be deploying that to the Ganache. So if you see, go back to the transaction, you can see the contract creation transaction. So that's all for today's session. We can go into the Q&A section. Okay, guys. So you guys can try it out, and if you guys have anything related to the before noon session or afternoon session, you guys can ask the question. So yeah, That's all the hands-on session is all about. Okay, so while you think or ponder for your questions, I'll just give you guys some pointers on if you guys want to like explore these technologies any further. So if you want to learn more about Solidity, you can visit this site. This is actually the official documentation. So it's a pretty fairly well documented and simple explanation of Solidity. Yeah, looks like it is taking some time to load. Yeah. So if you simply visit this site, I'll just paste it in the chat. So if you can go to this site to learn more about the Solidity. If you, like in any case, if you want to further pursue it, and in case if you want to learn more about a Remix ID, it also has a documentation. So go to this particular link. Okay, go to this particular link, then you will be able to learn more about the Remix ID. And if you want to learn more about the an actual Ethereum client, I mean, we won't be able to cover that in the scope of the session. So if you want to know about that, there is an Ethereum. I mean, this is the developer resources provided by the Ethereum developers itself. You have a lot of resources over here. You can use that also. Thank you, Rohit. So yeah, you can directly go here. And in any case, if you are wondering what are the application that is available on the, I mean, what are the conditions or applications that is available publicly on the network, on the Ethereum network that is actually hosted on the Ethereum main network. So you can use a site called State of the D Apps, where you will be able to see all the applications. These are the applications here. I mean, even the CryptoKitties. I'll just crypto. I mean, CryptoKitties are one. Yeah, I think CryptoKitties. I think I misspelled it. Anyway, you guys can just go ahead and search that. So all the current live applications, yeah, that's the CryptoKitties. And you can visit its website, see all the details regarding that. So this is actually a very good site. So yeah, you can refer to this site if you want to know more about the decentralized applications. So I'll just post that link over here too. And yeah. Ethereum developer. I had let me check. I need Ethereum docs and okay, so yeah, that's this. So if you want to know what the companies or the companies around the world are working on Ethereum, then you can go to this link and see their application. They have a lot of application in different areas, so you can go to this link and check out these applications and understand how the logic works on that too. So I think that's all the links I think I can provide you guys for the for further developing and pursuing this environment. I think I have pretty much given you the link, and if you guys want to have links, I mean, if you want to know more about the IPFS, it also has docs, right? Okay, I mean, even the IPFS has docs, so I would prefer IPFS instead of this application. You can go for that. And if you guys want any other reference link, and you can just put that in the chat and I will be able to provide that. Thank you guys. Thank you. So if there are no further questions, then we can wind up the session.
Okay. Okay, so very good, very nice session, I think.
Thank you.
Because yesterday there was some problem was there. Ma'am have a first session. They have the hands on, but ma'am handled it fast, and they have so many doubts. I think that doubts are being cleared.
Okay. Thank you for the opportunity too, guys.
Okay. So I would like to call Rohit to express his view on that session. Hello, Rohit. Hello, Rohit. Hello. 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 Rohit, are you there? Hello. Hello.
Hello?
Hello, Rohit. Hello.
Yes, sir.
Yeah, yeah. So you can say your opinion about your session. This session, two sessions was there.
Yes, sir.
Ma'am, your name actually?
Sir, my name is Sunila Shivtare.
Okay, okay, okay. It was showing another name here. That's
Yes,
right.
yes. This is my husband name.
Okay, okay, okay. Ma'am, please continue.
Yes, sir.
Hello, Sandeep sir. Can I speak?
Yeah, you can also.
Myself, Dr. Vishal Dahiya. My name is like male name, but I just really want to thank the sir because the first time I am going through what is actually the blockchain, and I'm a PhD guide. So my student he wanted to do in blockchain, so I'm learning it. So I'm very thankful to sir because today actually I come to know how these things will work and what is the future of this. So really I'm very thankful to him. Thank you.
Thank you, ma'am.
Hello.
Thank you.
Thank you.
Hello.
Ma'am, you can continue. You can continue. Hello.
Yes, sir.
You can continue.
Okay. Thank you, sir. Actually, this session is very helpful for me. Actually, there are many doubts in my in this subject, so many doubts are clear now. And really, this session is very helpful. Thank you, sir.
Thank you, guys. So if you guys still have any doubts, I'll just give you guys my contact email address. So if you guys want to know any technical doubts or need any reference link in the future, you can just mail me, and I'll reply you guys as soon as I see the mail.
Okay. Thank you, Anand. Thank you.
Okay. Thank you, guys. Thank you. Bye.
Okay. So today our technical session is over. Now we have a Sahaja Yoga session at 4 o'clock. I will make sure that they will end at 4:30. Okay. Okay, that's the only session. That's the last session of their. Uh, they have two sessions. So yesterday was one. Today they will continue with that. Okay. So please be on time at 4 o'clock. We will start that time. Okay. So materials, all the materials is been uploaded. YouTube link is been shared. Okay. So today's video is been recorded. It will be uploaded tomorrow. Okay. And details of the resource persons is also shared. Their CV is been shared with me. I will be sharing that in the drive. So you can use that also. Thank you. So one more thing, feedback link is been provided. Please go through the feedback. Please fill that. Okay. So next session we will start at 4 o'clock. Thank you.
ഒരു സാധനം കഴിക്കാൻ അവന്റെ ട്യൂഷൻ ഇട്ടിട്ട് 250 രൂപ ഞാൻ തരണം.
എന്തിനാ എന്നെ പിടിച്ച് ഇടിക്കുന്നത്? കഞ്ഞി കൊടുക്കാൻ അവൻ കഴിക്കണ്ടേ? വെള്ളം കഴിച്ചു. പൈസ ഇല്ലേ? പൈസ ഇല്ല, പൈസ ഇല്ലടി.
Good evening, one and all. Hope I am audible.
Yes, you are audible, ma'am.
Okay, today we are continuing yesterday's session, which was taken by Nargilkar sir. For today's session, we are having Mr. Chandrakant. He is working as Senior Technical Delivery Manager with Western Corporation, Pune. He has been largely associated with software and IT industry in India, USA, and Japan. He's actually voluntarily conducting the Sahaja Yoga meditation programs to various government organizations, colleges, and schools. On behalf of LBS College of Engineering and all participants, I welcome you to this session, sir.
Thank you very much, ma'am.
Okay, over to you, sir.
So, good afternoon, all respected participant. Today, myself and Vijay Nargilkar sir, we both are here today, and we are going to conduct a session. So, today's session structure will be within a 5 to 10 minute, we will be going to do a meditation, like how to balance our left side and right side. And same way, we need to do it at our home regularly. And then maybe we can take a question answer, which we could not able to take yesterday. So with us, the Vijay sir is there. So Vijay Nargilkar sir. So whatever question you have, maybe after 5-10 minutes, you can start asking to Vijay sir, and we can take this question answer. And as suggested by Sandeep sir, we are trying to finish around 4:30, but maybe 5 minutes here and there, but we'll try to finish at 4:30. So Vijay sir, you want to add?
Mr. Chandrakant, before you go to balancing a meditation, just a background to be given to all the participants who were present yesterday. What we have seen yesterday was awakening of the divine cosmic power inside us, which we call Kundalini. And most of you must have heard this name, Kundalini. It is a very much Indian Sanskrit name. And this power resides in our sacrum bone at the bottom of the spinal cord. Now, after the exercise yesterday, some might have felt cool on the one hand or both the hands, or on the top of your head, what we call as talu, fontanel bone area. Some might have felt slightly hotter, warmer, some change, some tingling happening. So these are different indications, and some might have not felt also, because it depends on the sensitivity of each person. So, but not to worry, because this has definitely happened inside every being. Now, it is just like sprouting a seed. You have put a seed into Mother Earth and you have put a water, so it starts sprouting. So that has to be nourished, properly looked after to grow up to some size, some height. Then the plant can withstand on its own. Same thing is here. Now it is the Kundalini is nothing but like a seed. Now it is sprouted. So we have to nourish it till we really come to some proper spiritual level. So, so there now we have to practice in our own house, morning or evening or both time for 10 to 15 minutes. Now, what is to be practiced, Mr. Chandrakant will explain. And then in Sahaj Yoga, there is a much more importance given for collective programs, like collective meditations, attending a collective different events. It is just like in Christianity, they go every week to church. In Muslim, they go to mosque once in a week. Similarly, even Hinduism also, they go to temple for different programs, for different pravachan or what you call seminars. Similarly, in Sahaj Yoga also, we have there is a much more importance given to the collectivity, collective programs. So we have to attend at least once in a week the nearest possible center. Or if you cannot do once in a week, at least okay, once in month to start with. Then you can increase the frequency. And at the same time, you have to practice at home, morning or evening or both times for 10 to 15 minutes. This is just to see that the seed which is sprouted is nourished properly, looked after properly to grow up to some size. And after that, you become your own master. That is what Srimati says, that you become your own guru because you have felt this Brahma Chaitanya on your central nervous system, and that will guide you, and your sensitivity will grow, and you can practically communicate with the Brahma Chaitanya, and you can become expert. So this is the this is the way ahead how we proceed further. Now to start with, because yesterday you have seen 3 channels, what we call nadis, and 7 centers in our being, what we call a subtle system, or sukshma sharir. Now these centers which are in the way passage of Kundalini while going up, what we call as Urdhva. So this condition of these centers sometimes is not so good. They act as blockages to rise the Kundalini. So we have to clean these chakras, we have to nourish these chakras, open these chakras, and so, till we reach to some minimum level. So how to clear these chakras? Because right and left nadi you have seen yellow and blue. Now how to get the balance and also open the chakras. Now, so there are different methods explained in Sahaja Yoga. Now Mr. Chandrakant will explain. Now these are the system to be followed to open our chakras, nourish our chakras, and also maintain the balance, and then meditation for a few minutes. That is how is what we call is the spiritual growth. So with this background, then I will ask Mr. Chandrakant to proceed, and after that we'll take question answer.
Yeah, okay, thank you, sir. So we will do the balancing in just 1 or 2 minutes. In 1 minute I will be going to explain you what we need to done, and then we can do the balancing and a little meditation, and the same thing you need to follow at your home. So sit comfortably. If you are sitting on a chair, you make sure that your feet are away from each other, like the same thing you can see on the screen. If you are sitting on a ground, maybe you can sit in Sukhasan, Padmasan, or whichever is comfortable position for you. So to clear our left side, you need to keep your left hand on your lap, palm will be facing toward the sky, and your right hand toward Mother Earth. If you are sitting on a chair, you can just direct your right hand toward Mother Earth, and if you are sitting on a ground, you can just touch your right hand on Mother Earth. And here we will wait for a few seconds. Then take your right hand back to your lap. Then we can do the right side balancing. So to do the right side balancing, keep our right hand on our lap and raise our left hand toward the sky, bending from the elbow like this, and our left hand palm will be facing toward the back side. And then slowly we'll take our left hand back to our lap. Then we will be sitting into the meditation position. Our both the hand on our lap, palm will be facing toward the sky, and we are just concentrating on top of our head at the center point. That's it, and we'll do a meditation. So all are ready? Can we do that? So I request you all participant, if you are wearing a shoes or slipper, you can just remove it so that your feet can touch Mother Earth. Be in a relaxed position. If you are wearing a tight watch or a tight belt, just lose it out little bit. If you are wearing a specs, you can remove, because now we are closing our eyes. So let's slowly close our eyes. We can thanks to Dr. Shri Nirmala Srivastavji or Her Holiness Shri Mataji Nirmala Devi, who invented or discovered this technique. So let's thanks in our heart and slowly we can close our eyes. धीरे धीरे हम अपनी आंखें बंद करेंगे. Slowly we can close our eyes. Let's slowly will close our eyes. With the closed eyes, we will watch our thoughts. But do not get involved. Just watch as a third person. Now our both the hand on our lap, palm will be facing toward the sky. Our spinal cord should be upright and straight. We are completely in a relaxed position. Now we are going to balance our left side, that is Ida Nadi or Chandra Nadi. So keep our left hand on our lap and raise your right hand and put on Mother Earth. If you are sitting on a chair, you can just direct your right hand toward Mother Earth. If you are sitting on a ground, just touch your right hand on Mother Earth. And here we will pray in our heart. Mother, please remove all the blockages, heaviness from my left channel toward this Mother Earth element. After the prayer, you may feel the flow of energy in both of your hand. So let's enjoy this flow of energy for few seconds. Now slowly take your right hand back to your lap. Now we are going to balance our right side, that is Pingla Nadi or Sun channel. So keep our right hand on our lap and raise our left hand toward the sky, bending from the elbow. And here in our heart, we will pray, Mother, please remove all the excessive heat, unnecessary thoughts from my right channel toward the sky element. श्री माता जी कृपा करके मेरे शरीर के अंदर की अतिरिक्त उष्णता, अतिरिक्त विचार आकाश तत्व में विलीन कर दीजिए. We may feel the flow of energy in both of our hand and top of our head. So let's enjoy this flow for few seconds. Now slowly take your left hand back to your lap. Now both the hand on our lap, our attention on top of our head. Don't do any movement. Now we are going to do a meditation for few seconds. Now slowly we can open our eyes very slowly. धीरे धीरे हम अपनी आंखें खोलेंगे. Let's watch on the screen. You may see both of our palm and top of our head. So at the same position, we need to just concentrate and observe the flow. You may feel a cool, you may feel a hot. So now slowly we can be relaxed. So this is the way we usually practice at home. So from here onward, we need to practice every day at home. Morning. Now we can have a question answer with Vijay Nargilkar sir. So I request you all participant, whatever you have question, you can go ahead and ask. Meantime, I am sharing one feedback form link on chat, and you all requested to fill that feedback form, and we can give you some more information as part of an email. So go ahead and ask the question. So there is a one question like how much time we should do this meditation every day. So maybe Nargilkar sir, if you can answer.
There is no hard and fast rule. To start with, you can do it for 10 minutes, but I am very sure once you start liking, you would like to sit more and more. What is called that this meditation, as I explained yesterday, is nothing but nirvichar, thoughtless awareness. You are aware, but you are in thoughtless. So thoughtlessness comes in a different way, like we are sleeping, we are unconscious, or so. But here you are fully aware where you are, what you are doing, who is around you. You are aware, but you are thoughtless. So once you start sitting in that state, you will enjoy more and more. You will feel very relaxed. You will feel peace inside. You will peace a very joy in the heart, and you will start loving this state to be in that. So what we suggest is that you practice slowly, but once you become slowly expert, you will sit automatically more and more time, maybe 15 minutes, maybe 20 minutes, because meditation is nothing but you are cleansing your inner the subtle system. You are cleansing. It gets fully cleaned, it gets nourished, it gets enlightened, and if there is any problem existing already, which in turn gives different physical, mental problems, and I can say different diseases also. So they will start disappearing slowly, and you will feel better. You will have good sleep. You will feel fresh, and you will feel energetic. Now and then automatically you will wait. When shall I sit for meditation, and how I can increase my time? So to start with, 10 minutes should be enough, but it should be a very sincere effort, and there should not be any doubt in mind, and sincerity is required.
Okay, so any more question? Yesterday, maybe we had many questions. Yesterday, someone is asking some question. Maybe we requested to send to Sandeep sir, or now you can ask directly if anyone has any question.
Let us ask Mr. Sandeep whether he has received the questions which can be read.
Hello, sir. Not much questions. They asked about the timing, when to do this session.
Okay.
For special, somebody have special medicines have been taking. How to so whether they can do this. That's what
They can continue for some time the medicine. We are not against. Question is when in the course of time we want to give away all the medicines, but not suddenly. You start practicing and you will improve yourself. You can check with doctor. Doctor will reduce your medicines slowly. So let us not suddenly jump from one side to another side. So as you practice more and more, your inner being will improve. Your level, the diseases will start disappearing slowly. So if you consult with doctor, doctor will change the medicine, may reduce the medicine. So that is how you have to go. And but one thing is very sure, very sincere effort is required, and without any doubt, because this system doesn't work with doubt. At least you take it as an experiment. If you suddenly don't want to believe, okay, but you be with open mind and assume you are experimenting, and once you get satisfied, then you should believe more and more, and the things will work better and better.
There are two questions, sir. One is how to improve our vision. That is one, and second question is like what should do after this meditation? Means what is more after this meditation?
First is the vision. Vision means the question is about the eyesight.
Yes, eyesight.
Eyesight. Okay, because vision has a different meaning. The eyesight will definitely improve. We have many examples. One of our colleague, he went to Air Force for interview and then medical checkup, and he was failed in the medical checkup due to eyesight, because the pilots, they have to be very good eyesight. So he requested the examiner, can you give me 15 days time, please, and I will come for. So in this 15 days time, he practiced Sahaja Yoga, and he went for medical checkup, and and his vision was acceptable, and he's still in the Air Force working. So we have many examples. So it will improve. Maybe while doing meditation or when you are looking at the photograph of Sri Mataji, you can remove your spectacles and you can sit in meditation, and slowly it will improve. But while doing meditation, you should not keep thinking all the time about my eyesight, my eyesight. You just leave it, because we want to go in nirvichar. When you are nirvichar, you don't worry for anything. And automatically the things will improve. Whatever is the shortcomings in our centers, in our physical, mental being, so it will improve. But we should not all the time go on thinking our problem. We should try to be in Nirvichar in that time, and after some time you can definitely go and check up. It will definitely improve. We have many examples whose vision has improved. Now the next question was, after the vision.
After the vision, what is next after meditation, or what is the next after this? Like how his meaning, I think, how to go more deeper in Sahaja Yoga, something like that.
Meditation, actually, meditation and this self-realization, that is to feel the cool breeze on your hands and on your palm, on your head, is the first step. It is the beginning of the spirituality in your being. And you are growing in the spirituality. What you call as a spiritual ascent, adhyatmic unnati. You are growing. Now, for that, there is no limit. But we call in Sahaja Yoga, first is self-realization, then you become nirvikalp state, then you go to tulya state, then you slowly start approaching to the God realization. So these are the different steps as you rise in spiritual level. So automatically, now the first step to achieve now, hereafter, is how to go to nirvikalp state. Vikalp means doubt. Nirvikalp means no doubt in our being about the existence of the creator of this universe, that is God. So slowly that doubt will go and the faith will increase, and to go to that state is the nirvikalp state. And after that, the tulya state means you become one with these 5 elements. Which are with us, that is water, earth, sky, these 5 elements. You start becoming one with these 5 elements, and you can communicate with the 5 elements. And but that is the state that is not to be shown to others, that is not to be utilized to impress others, that is not to be utilized for commercialization, for making money. Only we have to help with that state to others, how they can also grow. So these are different steps in spirituality, and you will enjoy more and more. It is just like for inner joy, what yesterday I told was Brahmanand and Niranand. For that state, there is no limit. You will start harping, when can I get time to be in that state? Our being only knows ultimately the peace and the joy inside. Our being doesn't want anything else. So that is the ultimate. If we pour crores of rupees on our head, we don't get joy inside. We get joy after seeing money, but that is very temporary, and we land into different problems. Whereas here, this joy is called absolute joy. It doesn't give any negative side. It is a cumulative effect. The joy will increase, your inner state will increase. Again, the joy will increase. So you go into that cumulative state. and you would like to increase more and more. So for the peace and for the inner joy, there is no limit. At the same time, your spiritual powers will grow. But I will not talk about the spiritual powers because we don't want to show these powers. We don't want to impress other people. We don't want to make money out of it. So that is what Srimati's advice to all of us, that this is to only to help all our brothers, sisters to come in this state and enjoy the real being, human being life. And we should not impress others or get some benefit after impressing or some commercial making money like that. So that is the teaching of our Guru Sri Mataji Nirmala Devi.
So I guess thank you, sir. There is no more question. I see. There are only if anyone has any question, last question, you can ask. Otherwise, we have almost completed with our session. So hope Sandeep sir, we completed at time. If anyone has any question, maybe we can take a last question. Otherwise, we are fine. So we thank you for Sandeep sir for giving this opportunity to interact with your participant faculties. And yes,
Chandrakantji, before you do thanking,
yes, sir.
I will request the participants. I find 25 or 26. Please avail this opportunity. Go to nearest center. You may be in a different city, in a different state, doesn't matter. In India, at least, every city has a Sahaja center. You go to the center, you start practicing, and it is to your benefit. It is free of cost. Only what you have to do is, with full faith, you have to practice. And once you develop the faith and you experience yourself, and there is no limit, sky is the limit. So we welcome you all for this Sahaja spiritual uh, passage to reach to the highest level. Thank you. Now, Chandrakant, you can close.
Yes, sir. So thank you, Sandeep sir, for this opportunity, and thanks all the participant who participated yesterday and today. We have this few follow up, like 2 or 3 week follow up, where we used to teach the foot soak technique, ice pack treatment, music therapy, and little more advanced thing which can help you to improve your health. If you are interested, you can let us know. We can conduct this kind of session free of charge in future also. So thank you, Sandeep sir. Over to you.
Okay, sir. Thank you very much, sir. On behalf of the
Thank you.
Computer Science
Thank you,
Department
Sandeep ji.
and LBS College of Engineering, we are very grateful to you for conducting such a session. Actually, the first time we are conducting such a session. Thank you very much, sir. And I expect future cooperation with you.
Yes, we definitely we can support you in future, no problem. So thank you very much.
Okay.
Thanks, Vijay and Nargilkar sir. Thank you.
Okay, Mr. Sandeep.
Okay.
Thank you, Sandeep ji.
Okay.
Thank you, all participants. Thank you.
Okay. So that's the end of today's session. Tomorrow, the same. We will have three sessions. Three technical sessions will be there. First one is a theoretical session, and the remaining two will be the hands-on, similar to the today pattern. And tomorrow at 4 o'clock we have another same a yoga session is there, conducted by Isha Yoga Foundation. So we can enjoy that also. So thank you for being present here. Okay. Thank you all.